What's up guys, welcome to your 35th Java tutorial, and in this tutorial I'm going to show you guys how to make a variable length argument list. Now I showed you guys how to build methods using multi-dimensional arrays and also how to build basic methods, but each time you did, you needed to tell it what arguments it took. But sometimes you want to build a method and you don't know how many arguments it took. So for example, say you want to build a method to average a bunch of numbers. Well, maybe you don't know how many numbers you want to average first, so you don't know how many arguments to give it. Well, in this tutorial I'm going to show you guys how to make a method that takes however many arguments you want. So let's go ahead and build a method outside our main method. Let's build a public static int, since it's going to be returning integers, average. And I just named it average. You can name it whatever you want. Now go ahead, and it's going to take an argument of integers, but you don't know how many. So anytime you don't know how many, what you do is put an ellipse, and that's 3 dots, and then put the name of the variable you want to use. And instead of putting int x, int y, int z, you just put 3 dots, and what 3 dots means is, alright, I'm going to be throwing numbers in here, but I don't know if I'm going to be throwing 2 numbers, 5 numbers, or 500 numbers. So dot 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 means just do it, and I'm not going to tell you how many numbers. So now that we have that, that's a new thing I wanted to show you in this tutorial. Dot 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 means you don't know how many arguments it's going to take. Let's go ahead and build a simple function. Let's just total all these numbers, so it starts at 0 since we don't have any numbers yet. Let's make an enhanced for loop. Set our variable equal to x, and it takes numbers in it, and let's just add all those numbers to the total. So total plus equals x, so it's going to loop through all those numbers and add them all to the total. So now after that we just need to return the average. So return total over numbers the length. So what this does, if you threw 5 numbers in here, it's going to return total divided by 5. If you only threw 3 numbers in here, it's going to return that total divided by 3. So number, which should actually be numbers, is what you passed into it, and the length of it is how many values. So that's how that works. So this is our method we just built. Now we need a way to output it on the screen. So go back to your main function so you can run this program, and just write system out, move my mouse, print line, and let's just print something like average, and then in here, in your average method, you can type however many numbers you want, 43, 56, 76, and 8. And let me go ahead and run this and show you guys. The average of this is 45. So that took 4 arguments, or 4 numbers right there. But let's say we wanted to add more, 65, 76, 2, and 31. Let's go ahead and run this. Does it still work? Yep. Interestingly enough, the average is only 44 for this. Interesting. So this is what this does. Anytime you want to build a method, this is the meat of this tutorial right here. Anytime you want to build a method that you don't know how many arguments it's going to take, so for example we pass like 4 the first time and 8 the second time, what you want to do is put what type it is, the ellipse, and then you just give yourself a variable that you can work with in your method. So again, that ellipse right there means I don't know how many it is, so I don't have to make it over and over again. So again, we just built the method right there and called it in our main function right there. So that's your quick tutorial on how to make a variable length argument list in methods that you build, so you don't have to write a new method each time you want to enter a different number of arguments. So practice that, and once you play with it a couple times, you'll get good at it. So thank you guys for watching. Don't forget to subscribe to my channel, and don't forget I'm gonna have this video able for free download, so make sure you do that if you want. So thank you guys for watching, and I'll see you next tutorial. What's up guys, welcome to your 36th Java tutorial, and in this tutorial I'm going to be showing you guys how to build a time class. Now what a time class is it's pretty much a separate class that has a bunch of different time functions, and I'm going to allow the user to enter 3 numbers, one for the hour, minute, and seconds, and it's going to convert that into military time and regular time. and we're going to be needing this information for the next couple tutorials, so make sure you build this with me. So first, let's go ahead in our tuna class right here. Make sure you're outside your main class, and I'm going to go ahead and build 3 variables, and they're going to be private variables. So not private, same thing, right? And make sure they're integer variables, one for hour, and another one for minute, and another one for second. So just copy that because I'm lazy, and turn this one to minute, and turn this one to second. So now we got 3 private variables, but now they have no value. So what we want to do is give them a value, and we're going to do that by letting the user input the numbers. So let's go ahead and make a method to do this. So public void, since it's not going to return anything, and just name it set time, or you can name it anything you want. But this is also going to take 3 arguments: int h for hour, int m for minute, and int s for second. So it's going to take 3 arguments, but we just don't want to let them enter any number they want. Since the hour has to be between 0 and 24, the minute has to be between 0 and 60, since that's how many minutes there are in an hour, and the seconds also have to be between 0 and 60. So what we're going to do is check this data before we enter it. So let's put hour is equal to, and instead of just h, let's go ahead and check it. So let's go ahead and write, let's just do this. Wow, would you look at that? If hour is less than or equal to 0, and you have to make an and because it needs to meet 2 conditions, and my ampersand is on 7. I put a bunch of stickers on my keyboard for After Effects, so now I can't see any of my symbols. I have to look on my laptop for it. So, and now if hour is less than 24, so if it's between 0, what the heck just happened there? I have caps lock on or something? No, just a funky little thing. Alright, now hour is less than 24. There we go, I messed up that time. So if these 2 conditions are met, and the question mark, are these 2 conditions met? Then hour. If not, 0. And why is this little green bar right here? There we go. Must have been something with my screen recorder. So here's what we're saying right now. If hour is greater than 0 and it's less than 24, then you can go ahead and use that number. If it's not, then go ahead and by default just put 0 so we don't mess up our whole program just because they entered the wrong number. So now we need to do this for minute and second. So let's go ahead and change minutes and change this to m, and change this to m and this to m, and then go to, guess what we're going to do next? Second, and change this to s, and this to s, and this to s. And make sure this HMS matches whatever you put up here. And now don't forget to do this. Instead of 24, go ahead and change these to 60. I know you gotta change all this. It probably would have been faster just to type it by hand, but well, we didn't, so too bad. So now that we got them to enter a time, and what this is going to do when we call this method right here, they're going to enter 3 numbers as arguments. So what we want to do is we pretty much set the time right there, but we have no way to display it yet. So the first way I'm going to display it is through military time. So, and that's the time where you can use like 12 to 24. So you'll see what it is later. So public string, since it's going to return a string, since it's going to display something obviously, to, make sure I had to spell military right, and it's going to take no arguments since it's just going to display, and in the body I'm going to return string format, and remember our format takes 2 arguments. Oh, they already put them in for us, how kind. Delete those. Kind but not kind enough. Why don't you fill in the rest of it for us? It's going to take, and remember in here you need to put percent, and where's my percent sign above the 5, O2D colon percent O2D colon percent O2D. Make sure I got that right. And what this is going to do is display the first one at 2 decimal places and then add a colon, display the second number at 2 decimal places, then add a colon, then display the seconds at 2 decimal places. And after that, let's just go ahead and add what we want to put in: hour, minute, second, and now that they're set right here, we can display them down here. So now just add a colon after that, and now we built everything we needed to. So now we can go to our main apples method right here, or apples class, excuse me, and we can begin building our objects. Since this was the tuna class, we need a tuna object for that. So tuna object, and remember you need an object so you can use the crap inside the class. So equal new tuna, and first let's just go ahead, and even though we didn't set a time yet, we can go ahead and display the military time just to see what it has for default. So system out, and let's just go ahead and print line and put tuna object to, what was it, to military. There we go, to military. And so we didn't set a time yet, so whenever we run this, make sure I don't have any X's anywhere, it should give us all zeros by default. So yeah, save those, and look at that, by default we get all zeros right here. So now that I lost my screen recorder, oh man, hopefully it's somewhere in there. Whenever I run this program, my screen recorder goes behind my Java, so I have no idea what's going on right now. Oh well. Anyways, that's really annoying. But anyways, let's go ahead and set the time now. So tuna, hopefully you guys can see this, object, and now we can go ahead and press set time. And of course this is going to take 3 arguments, and let's go ahead and press something like 13 for hour, and 27 for minutes, and 6 for seconds. And now once you run this, system out, well, we can just go ahead and copy this since we're lazy. Copy. Once after we set it, we can go ahead and run this again, and hopefully if I don't have any errors, we can go ahead and see right here. The first one was 0, that was before we set the time, and the second one, when we set the time right here, 13:27:6, what that did is converted it all to military time. And now I can see my screen recorder, but still behind. So now, dude, my screen recorder is messing up. Gotta remember, fix that somehow. So now, let me show you guys what we did. In our set time 13:27:6, we went right here, passed these in right here, 13:27:6. It checked if 13 was between this, it was. We checked if 27 was between this, and 6 was between this. Since it was, it used all the values and set them into hour, minute, and second. And that was when we put print to military, which was pretty much a display method. It pretty much just put them in this format and displayed them out to us, as you can see here. So in the next tutorial, I'm going to be showing you how to use not military time, regular American time, or I don't know what it's called, just regular time, I guess. So thank you for watching. In the next tutorial, you definitely want to watch, because we're going to need that information probably for the next few tutorials. So again, thank you guys for watching. Don't forget to subscribe, and I'll see you next time. What's up guys, welcome to your 37th Java tutorial, and in this tutorial I'm going to be showing you guys how to use our time class to convert time to a regular string instead of military time. Since, you know, not everyone uses military time, some people just use normal time, like 1:30 p.m. So let's just go ahead, and I'm going to show you guys how to do that. So we first need to make another method, and I'm going to name mine public, but I'm going to spell it right eventually. There we go, right there, you got it, buddy. Public string, and let's just name it toString, since this is just a normal string. You can name it like toNormal or something if you want, but you know what, I don't. So I'm going to name mine toString, and now we got a new method built. And what we want to do here is just return a basic formatting string. So let's go ahead and return string, just like last time. Move my cursor out of the way. Format. Why am I not typing right today? And now, once we do that, it's going to let us format this string how we want it. So the first thing that we need to do is, let me make sure I don't got anything messed up. String format. Looks good. First thing we need to do is give the format we want to put our time in. So for the first one, for the hour, we just want %d. For the minute, we want %02D, so %02D, and this is because the minute always has 2 decimal places. For the second, it's the same one, %02D, or 02D, excuse me. And for the AM or PM, we just want a string since it's just letters. So now, for the hour, we need to do something weird. We need to check if it's 0 or 12, then put 12. If not, then put the, well, you'll see what we do. So in here, go ahead and in your, well, just do as I type. If hour is exactly equal to 0, or if hour is exactly equal to 12, then what do we want to do? Well, let's just go ahead and put 12 for that. If not, else, if it isn't, then just go ahead and put hour modulus 12. Let me go slide this over a little bit. Maybe that'll be easier for you guys. So what we're doing here is saying, alright, if they put 0 or 12 for the hour, then go ahead and put 12. If they put anything else, then divide it by 12 and give our remainder. So if it's 13, put 1. If it's 8, put 8. If it's 14, put 2. Simple enough. The other ones are a lot easier, I promise. For minute, we just need to go ahead and type minute, since we don't need to do anything special with that. Second, just go ahead and type second, since minutes and seconds don't have AM or PM, only hours do. So now it brings us to my last point. We need to check whether it's AM or PM they're talking about. And there we go, right there. So how do we check if it's AM or PM? Well, we need to test the hour first of all. And if hour is less than 12, then what do we want to do? We want to go ahead and insert AM. Else, if it's not, let's go ahead and insert PM. So that's how we check for AM or PM right there. So now we got our basic 2 string, and we got a little error right there, and I forgot parentheses somewhere right here. I'll find it. I promise I will. I think I did. Oh, crap, this darn screen recorder is in the way. Let me pause this. Here we go. This was the one I forgot right here. Again, when you're doing your hour, make sure this one's enclosed right here, and make sure the entire thing is enclosed right there. But anyways, hopefully I don't have any more errors. Now that we got our basic string to string method built, we can go ahead and call it in our main function. So let's just go ahead, and right here we called the military one, and we can go ahead and copy this, and we're not going to use it again. I'm just too lazy to type to string. So the first one's going to call the military time, and the second one's going to call the string one that we just built. And by default, this is 0, and by default, this is 12. And if you're saying, alright, why isn't this 0, and why is it 12? Well, I'll show you right here. And right here, where we put, if hour is 0 or 12, then put 12. And it was 0, so it put 12. Since when you're looking at regular time, there's only 12 o'clock, and then it goes right to 1 o'clock. There is no 0 o'clock. I don't know if you guys knew that or not, but yeah, jot that in your notebooks. There's actually no 0 o'clock. So now let's go ahead and quit messing around with this crap and do what we came here for. We want to be able to set the time. So let's go ahead and put tuna. Actually, we probably want to put tuna object. And let's go ahead and use our set time function, and we want to enter 3 parameters. The hour, and we'll go ahead and change that to 13, which should be 1 o'clock in regular time. And then for minutes we'll put like 27, and then for seconds we'll put like 6 or something. Then go ahead and add a colon, and now we can go ahead and output these 2 again. And why type them again if you can just copy and paste them the lazy way? That's right, that's what I'm talking about. And now let's just go ahead and well, let's just go ahead and output it. Simple as that. So here's what we got. Here's our defaults that we got from last time before we set the time, and then we set the time. In military time it was 13 o'clock, 1300 hours, 27, 6 seconds. In regular time it is 1 o'clock, or 1:27 and 6 seconds PM. So that is how you use, here, let me recap this one more time. What we did is we pretty much just outputted the defaults on the screen. Then we went ahead and called set time, passing the parameters 13, 27, and 6. So it took 13 hours and converted it to hours. What was the next one? 27 and stored it for minutes, and 6 and stored it for seconds. It outputted that in our military format, and then it outputted that in our regular string format. So that is your basics of your time class right there. And make sure that you copy all this and follow along with me, because in the next tutorials I'm going to be teaching you new stuff, not about time, but we're going to be using this code right here. So make sure you copy all this and make sure your programs are working, and if they aren't, then leave a comment on this video and I'll try to answer it for you. So thank you guys for watching. Don't forget to subscribe. I hope you learned a little something, but not too much, and I will see you next time. What's up guys, welcome to your 38th Java tutorial, and in this tutorial I'm going to show you guys how to control access to different variables in other classes, and also what the this keyword means in Java. So let's first of all talk about access to these private variables right here. Now what private means is that these variables are private, meaning that only these methods have access to it. Only these methods in the same class, this tuna class, can use these variables. So what if we try to use these private variables in another class, like our apples one? Well, let's go ahead and try to do that right now. First of all, we already made a tuna object to use all the stuff in that class, but let's go ahead and try to use something like hour right here. If we go ahead and try to use hour and change it to like another number, we get this little error right here, and if we were to run this, we'd get a compilation error, so I don't want to do that. So what it says is the field tuna hour is not visible, and that is because instead of public it is private, again meaning that only these methods right here can use it. So if we want to change that and put it so these variables can be used in any class outside, we need to change that to public. And now you can see my little X went away. So now I can use a class outside to change the variables in another class. So let's go ahead and change it back to private, and make sure you spell it right, that's kind of important. And go ahead and delete this, and that brings me to another point. What the this keyword is in Java. So what if you're saying that, alright, I got 3 variables in this class named hour, minute, and second, but also in my constructor, or this doesn't even matter, it can be your constructor or just another function, or excuse me, method. I've been talking about C++ for too long. Changes the hour, minute, and second. So now we probably need to change these too, don't you think? Minute and second. So what if we were to say that these variables in this method inside this class were the exact same as these variables right here? So in other words, if the constructor or any other method uses names or variables identical to instance variables, then when you run the program, what's it going to do? Well, let's go ahead and see right now. I guess we don't need this anymore, but we'll keep it anyways. Let's go ahead and run this, and as you can see, we get 1 2 3 1 2 3, and then we set the time, which doesn't matter anymore. Then we get 1 2 3 1 2 3. So my point is this: anytime you have the same variables in a method or a constructor, which are the same thing, Java looks to these variables, the local variables, instead of these right here. So if we're saying, alright, that's good and all, and by the way, you should never name these variables the same as this. This is just for knowledge, but anyways, so what if we want to use these variables, the 4, 5, and 6 instead? Well, if a method contains a local variable with the same name as the field names right here, then the method is always going to look at the local variables instead. It's always going to look at these instead. And that is, there is only one way to kind of overpower this, and that is to use the this reference to refer to these variables instead. So for example, you know we had 1 2 3 1 2 3 1 2 3 1 2 3. Well, if we use a little keyword called this instead, then it's going to refer to these variables. So this hour, this minute, and this second. And this pretty much means this method right here that we're talking about. So anytime you use this, it says, alright, don't use all these, use this right here. And I'm sure that's a tone when he was creating this. Use this one right here. I'm sure he said that. So now if we go in our main apples program and go ahead and run it, we now get 1 2 3 1 2 3 before 4 5 6 4 5 6. So that is using these local variables instead of these private ones right here. So again, anytime you want to use the variables in your method instead of the variables outside your method, if they're named the same thing, you need to use the this keyword, and that says, alright, use these ones right here, or use this ones not here. That doesn't even make sense, but you know what I mean. Use them locally instead of far apart. So again, it's easier just to see and play around with it, and once you do, you're going to understand what this means. Wow, that's like a little joke. And anyways, hope you understand at least a little bit. In the next tutorials, I promise I'll be clearing this up for you. It's kind of confusing right now, but keep an eye out for my next tutorials. Don't forget to subscribe, and I'll see you next time. What's up, guys? Welcome to your 39th Java tutorial, and in this tutorial I'm going to be talking about overloaded constructors. Now, you guys already know what a constructor is. It's pretty much a method with the same name as that class, and whenever you create an object, it automatically calls that method or does that method. So I told you guys how to build a constructor, and I told you guys that you can build only one constructor with the same name as the class. But I didn't tell you guys that you can build multiple constructors, and depending how many arguments you have, it picks what constructor to use. For example, if you called that object with one argument, it would have a constructor for that. If you called that object with 3 arguments, it would have a constructor that took 3 arguments. So let's go ahead and do this right now. So we first need our 3 variables, private int hour, and then we need that same thing. Let me put a semicolon instead of colon. We need that same variable with minute and second. Minutes and second. Now let's go ahead and build our first constructor. And we do this by putting public tuna, since tuna is the name of the class, and I'm not going to have any arguments for this one. We're going to do one with 0 arguments, 1, 2, and 3. So when you put one with 0 arguments, what we want to do is eventually we want to give it 3 arguments. So what we would do is put this keyword, and what this does is pretty much invoke the constructor again, but give it 3 arguments this time using 0, 0, and 0. So now we need to build another constructor. So public, actually we can probably just copy this. Copy, we're lazy, and paste. Public tuna, but instead of 0 arguments, this one, if they pass in 1 argument, what are we going to do? Well, if they pass in 1 number, then let's just assume it's the hour. So we put this hour, so if they passed in object 5, it's going to be 5 o'clock, then 0, 0. So now let's build another one, and this one's going to have 2 arguments. This one's going to have an hour and a minute. So int hour and int minute right there. So now what we want to do is invoke hour and minute, and again what this is going to do is call this constructor again, but pass it 3 arguments right here. So now you're saying, alright, if we call this constructor again, it's going to look through this one, see where there's 3 arguments, look through this one, see where there's 3 arguments, and look through this one, see where there's 3 arguments. And that's why I'm getting an X right here. It says the constructor tuna is not defined, because we keep calling a constructor with 3 arguments, but we didn't build one yet. So let's go ahead and build one right now. Let's go ahead and put public tuna, and I could have copied that, but int hour, int minute, int second. And if you watch, all of my X's just disappeared. So you see they're now up, and then once we finally build one, it disappears. So now that we have a constructor with 3 arguments, we can go ahead and build something what it does. In fact, I'm going to build another, I'm going to have it call another method right here that sets the time to hour, minutes, and seconds. And we're actually going to be building this in the next tutorial. Actually, we can probably build it right now. We have enough time. But let me explain to you first what this one does. If a user was to create an object with 0 arguments, it would give it 3 arguments by default, so it can go down here to this constructor. If a user was to enter an object with 2 arguments, it would go to this one. It would use the first number as the hour, the second one is minute, and the third one is 0. And then it would call this constructor again with 3 arguments, and the only one with 3 arguments is this. In hour, in minute, is second. And then what this constructor does is set the time in a set time method. And you're saying, alright, where the F is that method? Well, we're going to build it right now, so take it easy. Let's go public void set time, and as the arguments, again, what we want to do is take 3 parameters, int h, int m for minute, and int s for seconds. Now in the body, let me scroll up a little bit. There we go, not bad. In the body, what do we want to have to set the time? Well, actually, we're going to be building 3 methods for this as well. And I know it gets confusing, but set hour, and this is going to take an hour. Set minute, and this is going to take a minute. And set second, and this is going to take a second parameter. And now once you close this, it says the method set minute is undefined, and we're actually going to build 6 more methods. I think we're going to build methods for setting each of the times. And why do we need a new method for set hour, a new method for set minute, and set second? Well, we can't just have any hour they type in. We need to build a method for it, like last time where we set the hour, we had to check if it was between 0 and 23 or 24. And set minute, we need to make sure this is between 0 and 60, and also for set seconds. And we're also going to make another method for get method, not get method, for get hour, get minute, and get seconds. And that's just going to return everything. But we're going to be doing that next tutorial. But if you still don't know why I'm having separate methods for these, it's so only these methods can access the hour. And down here, as I said in last time, we don't want any other class to have access to this information right here. So that's why we need to build a separate set and get methods for each hour and like hour, minute, and second. But anyways, that was supposed to be for next tutorial. That was just a little jump ahead. The meat of this tutorial that I want to tell you is right here. Let's see. Yep. These are all constructors right here. One with 0 arguments, one with 1, 2, and 3. And I just want to tell you that you can build different constructors depending on how many arguments you have. That way, you don't really need the user to enter one specific set of information. It varies, and then depending on how much information they entered, it does a certain task. So if you don't understand this, I promise in the next either 1 or 2 tutorials, this will make all sense once we finally build our program and you can see what's going on. But thank you guys for watching. Make sure to write this code right now, and again, like I said, by the end of these tutorials you're going to understand why we did it and how this all works. But for now, thank you guys for watching my tutorial on overload constructors. Don't forget to subscribe to my channel. It is the best channel ever. Again, thank you guys for watching, and I'll see you next time. What's up, guys? Welcome to your 40th Java tutorial, and in this tutorial we're going to be building the set hour, set minute, and set seconds methods. Now, we already got the data from them, the data that we need in the last tutorial, so hopefully you watched that because you need this code anyways. But if you did and typed everything up, then that's good, you're good to go. So let's go ahead and build first the set hour function, or excuse me, method. The same thing as a function pretty much. I just been around C++ all day, so anyways, public void, since it doesn't return anything, and set hour, And what argument does this take? Int h. It takes just the hour, since again we're only setting the hour, nothing else. Now in this, what we want to do is check if the data is between 0 and 24, and if it is, it's valid. If not, we're just going to set it to default like 0 or something, and by or something I mean 0. So let's take that hour, and first let's make a simple if statement. Is the hour greater or equal to 0 and, where's my and? 7 right there. Again, I put stickers on my keyboard, so it's kind of annoying. And is the hour less than 24? You're going to say, alright, if that is true, then you can go ahead and use the hour. Else, if it's not true, go ahead and put 0. So again, this is a conditional expression, or it's pretty much just the same as an if statement. What this is going to do is check if that hour is between 0 and pretty much make sure that the hour is greater than 0 and less than 24, and if it is, use it. If not, use 0. So now do the same thing for minute and second, except when we use this, we want to change hour, minute, and second, and we also want to change this minute and second, and we also want to change this minute, and don't use a capital, and second, and also want to change this minute, second, and instead of having, let me check this data real quick, minute, instead of having 24, you want to change these to 60, since with minutes and seconds, it doesn't need to be between 0 and 24, it needs to be between 0 and 60. So that's why we do that. So now that we got our hour, minute, and second built, what's this say right here? Duplicate method, second, hour, and type 2. That's good. We're good to go. Hour, minute, second. What we need to do, this is what it was saying right here. Set minute and set second. So then, now that we got our check for hours, our check for minute, and check for second, what we can do now is write get methods just to get them. Since we write a set method to change data if need be, if it's bad, and we need a get method to pretty much when we're retrieving our data, this is what we need this method for. So let's go ahead and write public int, and the first one we want is get hour. So get hour, and this is going to take no parameters, and what it's going to do is, this is the easiest thing you'll do all day, get return hour right there. So what this is going to do is pretty much take this and return it. So let's copy this and keep up with me, because it's going to be a little too easy. Get minutes, and this one's going to return minute, and get second, and this is going to return second. So now that we have 3 set statements and 3 get methods, set methods, get methods, we need one more method, and I promise this is the last one. The last method that we need is pretty much just a formatting method, and this pretty much just spits it all out, or a display method. So like last time, I'm going to put public string, since this is going to return a string, and after string I'm just going to name it, I'll put like to military time, since we'll do military time. Military time is a lot easier than normal time, and this isn't going to take any parameters since it's just going to return a string. So what we want to return is, let's go ahead and write string format, and again it tells us we need 2 arguments, and the first argument is, let me get rid of this, it annoys me. The first argument is how we want to format. So we want to format %02d, %02d, colon, %02d. So %02d, 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 and this means the hour, the minute, and the second is each going to have 2 decimal places. So for the first one, for the hour, it says what number do you want to use. Well, we want to use whatever number was returned in our getHour method right there. For our second one, for our minutes, we want to use whatever was returned in our getMinute method right there. And for our last one, of course, getSecond right there. So now these functions, let me double check this, make sure it's good. These functions are good to go. We built all the methods that we need. And again, whenever I say functions, I really mean methods. I'm just another language. Those methods are all we need. So now we can go in our main apples class right here, and we can begin building our objects. Now again, whenever we're going to go ahead and create 4 different objects because we had 4 different constructors. And actually I'm going to be doing that in the next tutorial. So as you can see, we have 1 constructor, 1, 2, 3, 4. So in the next tutorial I'm going to be building 4 different objects, each to use these constructors in 4 different ways, and then I'm going to be summing up and telling you how this whole program works and actually what the heck we just did, and then you're going to understand it awesomely. So thank you guys for watching. Don't forget to subscribe, and I will see you next tutorial. What's up guys, welcome to your 41st Java tutorial, and in this tutorial, as promised, I'm going to be building 4 different objects, and these objects are going to use this tuna class, and depending on how much information they have them, they're going to use a different constructor for each one. So let's go ahead and do that right now. So let's get some spacing right there so you can see it good, adjust my headphone, and bam, I'm good to go. So in order to make objects, let's go ahead and name this tuna object, and we'll set this one equal to new tuna, and this isn't going to take any arguments at all. So if we go look in our tuna class right here, and you know that it has no arguments because nothing's in here, we look at which one of these constructors has no arguments. Well, this one has an hour, this one has an hour and a minute, that's 2 numbers, this one has 3 numbers, but this one right here has no arguments right here. So what it's going to do is insert 3 arguments and call this constructor again. So then it's going to go down here where this one takes 0, 0, 0. It's going to set the time to 0, 0, 0, and then set the hour to 0, and minute to 0, and second to 0. So now that we have that, let's go ahead and build some more objects, but this time let's give them different parameters or different arguments. So let's go ahead and copy this and paste, 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 and we'll name this tuna object 2, 3, and 4. And we'll give this one, tuna object 2, we'll give it 1 parameter. We'll give it an hour of 5. We'll give tuna object 3 2 parameters. We'll give it an hour of 5 and a minute of 13. And we'll give tuna object 4 an hour of 5, minute of 13, and seconds of like 43 or something. So for example, this one right here, it has 2 arguments. So it's going to look at this constructor right here. Is this constructor good for me? No, this has 0 arguments and I got 2. So I'm not using you. What about is this constructor good for me? Well, I got 2 numbers and this one only lets me insert 1. So I ain't using you. What about this one? Well, this has 3 and I only got 2. So I don't think so. Oh, bam, the last one's just right. I got 2, you got 2. Let's use it, baby. So that pretty much what happens with these objects. That's what's going on right now. But now that we got these objects, let's go ahead and actually use them. And so let's just go ahead and print out the time. So system out printf. We'll just do a simple print format. And again, this takes 2 arguments. The first argument is how you want to format it. And I want to format it, and since we're going to be using this right here, public string to military, this returns a string. So we probably want to put percent string with a new line right there. And actually, new line goes this way, I believe. That would have been embarrassing. And so this one returns a string. So now we can use our tuna object and then put something like 2 military with no arguments. And what this is going to do is it is going to return our tuna object with no arguments right here. So let's go ahead and we might as well do the other ones right now while we got this nice and copied. This is tuna object 2, 3, and 4. Now let me run this and make sure I don't have any errors, and hopefully it runs right, and bam, look at this. Now the first one was object, it was just tuna object, and we didn't enter any parameters. The second one, we entered a 5 for the hour, and it filled in 0 for the rest. The second one, we entered a 5 for hour and 13 for minute, and it filled in the rest to 0. And this last one, tuna object 4, it filled in all of them for us, or actually we did it ourselves. So let me see if I can position this right, since my screen recorder is messing up again. And now let me go through one of these and show you guys exactly what it did. Not dud. Why the heck did I say that? So anyways, let's just pick one that you can understand easy. And how about tuna object 3? Right here we made an object that had 2 parameters right here, 5 and 13. So it went to tuna where it creates everything, and it went to our constructors, and it says, alright, which one of these constructors has 2 arguments? This one has 2 arguments right here. So I'm going to use this one. This one has 0, 1, and 3. So I'm going to use this one that has 2. Well, what it did was plugged in, what was our numbers? 5 and 13. It used the 5 for hour, the 13 for minute, and it used the default of 0, and it called this constructor again, but this time it used its 3 new numbers. So whenever you use the 3 numbers, it uses this constructor right here, and what this constructor does is set time. It calls the set time method. So now it says, alright, I'm going to send you to the set time method. So let's scroll down and see what the set time method tells us to do. Well, it tells us to do 3 more methods right here. Set hour was pretty much check if it was between 0 and 24, which it was. It was 5. Set minute checked if it was between 0 and 60, which it was. And set second, that was that 0 it plugged in for us. That we didn't have to do anything for that. So then we said, alright, we're good there. So then when we finally called the 2 military method, what did it do? Well, it pretty much just said, alright, we want to use this method for that object right here. So what we're going to do is get that hour, which was 5, get that minute, which was 13, get that second, which was 0 by default, and I'm just going to return them all to you in a nice, pretty looking string format right here. So that is why whenever we called this to military, it just outputted the string right down here, 5130. So that is, of course, a very complicated way, but again, you need to know it, on how you can use overloaded constructors to, let me scroll down here, to make a bunch of different constructors based on how much information you enter. And in that example I just told you, since we entered 2, it picked this constructor. And that is how you can pretty much use different objects with different amounts of information in it. So this will be clear when pretty much we're building more programs. And this was just an example, so it might be a little fuzzy right now, but you'll understand eventually in the next couple of tutorials. So thank you guys for watching. Hopefully you understand at least the basics of overloaded constructors and how they are useful when creating objects with different argument lengths. So again, thank you guys for watching. Don't forget to subscribe to my channel, and I will see you next tutorial. What's up, people? Welcome to your 40-second Java tutorial. And in this tutorial, I'm going to be going over a built-in method that Java has. It's called the toString method. And I'm going to show you guys what it is and why it's useful. And we're also going to be building part of a bigger program. This is probably going to be a 2-part tutorial, so pay attention and it's going to be sweet. So the first thing that we're going to need to do is get 3 variables. And they're all going to be private. And they're going to be month, day, and year. So private int month, and just go ahead and copy and paste that. Take advantage of our laziness. Control V, int day, and private int year. So now we have 3 variables right there. So let's go ahead and do something with them. The first thing that we're going to want to do is build this PopPy. Again, you can see him on the PopPy class. So I'm going to build the PopPy constructor. So go ahead, public, and just go pop-pie. And it's going to take 3 arguments. It's going to take int m for month, int d for day, and int y for year. Again, you can name these anything you want, not important, but remember to set your variables, which are your private variables, like month, equal to whatever you corresponding letter. I just put m, d, and y for obvious reasons. So that private day variable is going to be set to whatever we pass in for d, and that private y is going to be set to whatever we passed in for y. So now we got our constructor, but we want our constructor to do one more thing. We want it to print out a string. So, and we just want it to print out so we can know that our constructor worked or didn't work. Make sure you put an equal sign right there. So let's go ahead and system out printf. We can just print format, and I already started filling them in for us. So let's go ahead and print out a string. So let's put come on, Haas. Let's put the constructor, make sure you spell it wrong, for this is, and then we'll go ahead and put %s, and that means string, and then go ahead and put a new line if you feel like it. If you don't feel like it, you know, you don't gotta. And now, as you can see right here, our C style format, it takes one string argument. So in our second argument, just go ahead and write this, and when we write this, what it means is this, the keyword this, what's highlighted right now, this is just a reference to whatever object we just built whenever we call this class. So it's going to say, alright, then what the heck do you want me to put for a string? Well, that's what we're going to be going over in this tutorial right now. Anytime that you need a string representation of an object, Java built this thing called a toString method. So let's go ahead and write public, and we're going to be building that right now. Public string toString. And I know most of the time you can call your methods anything you want, but you can't. You have to say toString in this case. And go ahead, and it takes empty parameters, and in your body of your method, go ahead and return whatever format you want. So return string format, and then go ahead and percent. WTF does that mean? Go ahead and put this. I mean, you can write it in whatever format you want, but just follow along. %d, %d, %d. That's the common date format, and that has the month, day, and year. So the month / day / year /. So this is what this is going to do. Well, let's go ahead and finish our tutorial, and then you can probably see what it's going to do. Then I'll talk you through it one more time. What we need to do is go ahead and create an object now, and I'll call it potpie, and I'll just call it like something like pot object. That pot object is not important. You can name whatever. New potpie. And I know I should have like proper months and days and years, but I should have 4, 5, 6. 6 seems like a good year, a long time ago. So now that we go ahead and create this object, we should get a nice little string at the end if I didn't mess anything up. And it says the constructor for this is 4, 5, 6. So now let me take you guys through exactly what I did. What I did is create an object using the parameters 4, 5, 6. So let's go ahead and look what happened when I created that object. It said, alright, since the first thing I'm going to do is this constructor, I'm going to pass the parameters 4, 5, and 6. And for month was equal to 4, day was equal to 5, and year was equal to 6. What the constructor also did is say, alright, every time I create an object, I want you to print out this string. But we had in the string variable, instead of an actual string, we had a reference to an object. And anytime you reference an object and it needs something in the string format, it looks to this method right here. What this method says is anytime you need a string representation of this object, you look to me. I'm toString, I'm built in Java, that's what I'm for. So that's why it outputted this right here. The constructor for this is 456. This is where that format 456 comes from, right here. And in the next tutorial, if this seems kind of confusing, I'll show you guys a useful way why toString is actually used, and not only, you know, it might be a little confusing to understand. I mean, this is just an example, it doesn't really do anything, but in the next tutorial I'll show you guys like one example where we would actually need it and use it. But for now, hopefully you get the main idea. Again, the key points is the probably two things you're going to be confused upon is this. I mean, what's highlighted right now. Anytime you use that keyword, this, it's a reference to the current object. So it's going to say, alright, just reference the current object. So it implies that it needs a string. So since it needs a string, it says, alright, I need a string here. It says, oh, I see, that's why it gave me this toString method. So anytime I need a string, I know where to look. So, makes sense. And if it doesn't, it will in the next tutorial. But for now, thank you guys for watching. Hopefully you understand the basics of a toString method. And don't forget to name it toString. That's very important. So again, thank you guys for watching, and I'll see you next tutorial. What's up guys, welcome to your 43rd Java tutorial. And in this tutorial we're going to be building the rest of our program, and I'm going to be teaching you guys about something called composition. Now what composition means is that it means that a class, and this is the one we're going to be building today, instead of just variables and methods, it can also have references to other objects for other classes. And it could, well, I'll show you guys what it means. So go ahead in our tuna class. Again, in the last tutorial we built this PotPie class. In our tuna class, just clear everything out, and we're going to have two members for now. Go ahead and type private string, and this is a new one, name, and that's gonna be used just to store my name or something. And we're gonna also have a reference to another class, the PotPie class. So go ahead and type private PotPie and type birthday, since this program is just gonna output my name and the birthday, but it's gonna do it in a cool way. So now that we have two members of this class right here, we have a new name variable and we have a reference to a PotPie object object. So let's go ahead and, well, let's use it. So the first thing we want to do is build our constructor. So this class is named tuna, so we have to name our method tuna, and that's constructor. What this constructor is going to take is two arguments. It's going to first take that string variable that we have, and we'll just name it the name so we don't forget. And we also want a reference to our PotPie date object. So let's go ahead and put PotPie, and let's go ahead and write the date, or you can write the birth date or something like that. And now in the body of our constructor, let's just go ahead and set name, set it equal to the name, and let's go ahead and set birthday that we declared up here, and set it equal to the date. So now we are in sync, we are good to go. But what we want to do now is go ahead and make another toString method. So let's go ahead and put public string toString, and just like we did in the PotPie class, in this method it's going to take no arguments, and for the body we want to return a string, of course. So string format, and for a format, I don't really like when it fills it in for you. You know, I want to do the work myself. And in our format, just go put my name is %s, and that's going to fill in your name. And then let's go ahead and put my birthday is %s. And here's where it gets kind of tricky. Name, birthday. So now, if you guys can understand the next thing I'm about to say, you'll understand the next thing I'm about to say. It sounds easy enough, but you'll understand the key concept of this tutorial. So now, whenever we need a string representation of this, what we're going to do is this. It's going to return my name is, and it's going to look right here to see what it wants to fill in for name. Well, the name was up here, and it's going to be whatever we gave it, passed it in. But for birthday, there isn't a really string named birthday. Birthday is just a reference to the date object. And again, what this means, since it's a reference to an object and not a string, anytime it needs a string from an object, it's going to say, alright, anytime you need a string, and I'm only an object, I'm not a string, maybe I can help you out. Well, I'll go to my class, and I'll go to the toString method, and then I can give you the information that you need. So when I put %s right here, you don't necessarily need to pass in a string object, or excuse me, a string variable. What you can do is pass in an object instead, and whenever it looks in that class, it implies via the toString method that this is the string you're looking for. So again, you can do two things when you're using this. You can either pass in a regular string, which is just like a bunch of letters, or you can pass in an object, and whenever you do pass in an object, it looks in that class and it looks to the toString method of that class. So that's two different ways when you're using the print format that you can do that. So now that we got a toString method, which is pretty much the string representation of an object in the tuna class, and we got a string representation of an object in the PotPie class, I think we're ready to build some actual objects now, put them to use. So go over in your main Bucky, or I don't know, whatever you named it, and let's go ahead and build some more objects. One more to be exact. So now that we already built one from PotPie, we probably don't even need that anymore, but we'll keep it up for good looks. What we want to do is build one for tuna. So tuna, ooh, got the hiccups. Tuna object, make sure I typed everything right, got the hiccup in between there. And new tuna, and now we need to pass in two variables. Again, this is going to take two parameters, because look, our constructor takes two parameters. It takes a name and it takes an object. So for the name, let's go ahead and pass in Greg, and for the object, let's go ahead and pass in pot object that we just built right here. So in order to see what parameters it takes, look in your tuna constructor, and you can see it takes a string and it takes an object. Well, our string is Greg, that's my real name, and our object is pot object, and we just built it up here. Now everyone knows my real name. Oh great. So now let's go ahead and just output what we did. So system out print line, and let's go ahead and just write tuna object, but we have to spell it right, and we better change that to Bucky for good looks. And now let's see, I should be good to go. So let me run this, see how many errors I got, and then I'll talk you through one last time what we did. And it says my name is Bucky, birthday 456. You got it? So in the first line, in line number 3, we built a constructor. In the second line, we built a tuna object. Well, I guess we built objects in both lines, but here's what it did. You guys already know what this one did from last tutorial. For the tuna object, when we built it in the constructor, we passed in two arguments: my name and this object right here. It took the name and set it equal to name, and it took the object and set it equal to birthday, and then it says, alright, just return it in a string format. Well, my name is Bucky, easy enough. My birthday is this object, and it says, alright, how am I going to turn an object into a string? Well, anytime I want to turn an object into a string, I just go to that class and go to the toString method. So again, I'm going to repeat it. Anytime you want to turn an object into a string, it looks to that class in the toString method. So that is your quick tutorial on what the toString method is. And also, again, like I said, this is called composition, and that's referring to objects. Let me show you guys. That's referring to objects in other classes as members. So this was composition right here. So thank you guys for watching. Let's see how much time I got. Oh, just in time. So thank you guys for watching. Make sure to check out my next tutorial. Get out of my White House. And make sure to subscribe to my channel because, you know, it's the best channel ever. So I'll see you later. What's up guys, it's Bucky. Welcome to your 44th Java tutorial. And in this tutorial I'm going to be going over something called enumerations, or enum. We learned about them before, I think. We might not have. If we didn't, you know, no big deal. We're about to learn it today. But the first thing that we're going to do, well, let me tell you what enumerations are. They're pretty much kind of like classes, but you're going to use them to declare constants, at least in this tutorial we are. So let's go ahead, and anytime you want to do this, instead of public class tuna, you put public enum, E-N-U-M, and now you can use this in a specific way. So like I said, the first thing we're going to want to do is declare a bunch of constants of the enum type. So let's go ahead and make some constants, or these are pretty much going to be like variables that never change. So I'm going to make like 3 names, Bucky, and these are in essence objects. So let me give these a few parameters and then you'll see why later on. Bucky, let's give the first parameter a description word of the object, and I'm going to put nice, since, you know, I'm doing this tutorial, might as well say something good about myself. And then let's just go ahead and put a string about like how old they are or something. I'll make it interesting for the other 2 ones. Now let's think of a next person. Let's think of we'll do constants of my first girlfriends. So my first one was Kelsey, and she was a cutie. It was 5th grade. She was pretty cute. And let's see, when I went out with her I was 10 years old. And now I'll put a comma because we're not done with our entire enumeration list. And then the next girl I went out with was, well, it wasn't really a girlfriend, but we had a thing. It was Julia. She was a big mistake, and I was 12 years old when I went out with her. So now we're done. We got 3 constants. Let's go ahead and end this statement with a semicolon. Now what we're going to do, since we just made objects, and again each constant is an object, and it's going to have its own set of variables in this entire enumeration. So let's go ahead and give it 2 variables that we're going to use later. Private final, since we don't want them to change, string, since that's what we just made, since we're in quotation marks, and we'll put DSC for description, and we'll copy this entire thing, copy, paste, and we have description right here, and what's a good name for this? Year or something. Year. So now we have 3 objects, which are actually enumerations, we call them, or constants, and they each have a set of their own variables, 1 for description, 1 for year. So now what can we do? What do we usually want to do when we create these? Well, the first thing that we're going to want to do is create an enumeration constructor. So let's go ahead and do that by, of course, typing the name of your class, and then you probably want to put your 2 variables in. Put string, description, and make sure, since this is we're gonna use this, make sure this is different than this, and you should know why. And then just put string, and let's put birthday or something. It isn't their birthday, but I don't want to get confused at all. I can't put YR or something because it would just confuse me, you know. I'm easily confused. Got something to say about it? Didn't think so. So now let's put DSC, or whatever you declare it up here. Just put it equal to description statement, and then go ahead and put birthday year equal birthday. And now what do we got? Anytime, here's what's going to happen with Bucky. It's going to say, alright, with the object Bucky, give it 2 variables, a description and a year. For the description, pass in nice. In this 22, we're going to see is birthday. So set year equal to birthday. So now we can work with DSC and year. Good enough? But now that we have a constructor, we just pretty much set these variables equal to where they need to be. We have no way of getting the variables yet. So let's go ahead and create two methods that we can get the variables. So public string, since it's going to return a string, and put get description or get des if you're lazy, which I am, so hey, it works out. And then in this one we want to return the DESC. That's just going to return a string of the description. Easy enough. And guess what we're going to do in this method? Public string get, I'll put get year. Seems like a good name. And this one is just going to return year. The only problem with this, it's a little too easy. So now this is all we need to do with enumerations. Again, enumerations are constants that are also objects, pretty much. And so we needed two variables to represent the two arguments. And then once we have those two variables, we can build a constructor. And then this constructor allows us pretty much to set these variables equal to each other and return the information we wanted. So let's go ahead and, well, let's just go ahead and use that information right now. So what we want to do pretty much in our main class right here with our main method is build an enhanced for loop. So let's go do that right here. For, and the first parameter you need is of course the class name and the variable that you want to use in your for loop. Like we used like description right here. This is just a variable that we just made up. This is going to be the variable that we just made up right here. And that's the first, like, it's pretty much what you want to call your objects when you loop through them. The next argument is you need an array that you need to loop through. And let me tell you a little bit about this because this might be kind of confusing. Anytime you make an enumeration like this, Java automatically takes this constant, these constants, and makes a built-in array. And the array is called whatever your enumeration is called, and since I named my tuna, it's called tuna. And when you write values like that, this is a built-in array of the constants right here. So if we're saying, alright, I need an array, bam, you got an array right there. And again, you can't change this keyword values. This values is called a static method, and again, this is how you get a built-in array. So this is going to loop through each of the constants. First it's going to loop through Bucky, then Kelsey, then Julia, and it's going to assign them to people. Well, you'll see what it does. So now we just need to make a print statement. So let's go ahead and put system. And why do we need to make a print statement? So we can actually see what's going on. System out printf. And let's just go ahead and make our two arguments. The format is going to be %s, and let's put a tab, add some spacing, %s, add a tab, %s, and a new line. So it's going to write our name, our description, our age, and then it's going to go to the next person. So now we need our arguments. The first thing we want is people, because that's what the object is pretty much. So in the first one, it is just going to loop through our name, which is this, Bucky. In our next argument, what we need is to take that people object and use the method get, wait, what did I name that method? People.get description. And what that is going to do is it's going to return a let me find my screen recorder, see how much time I'm at. I got minute 30. What it's going to do is return a string of our description, and this last one, people.get year. And what this is going to do is, first of all, I need to get, it messed it up for me. People.get year. And what this is going to do is return a string of the year. So let's go ahead and make sure I have a semicolon at the end of that. And 1 second. And make sure I have this. And let's go ahead and run it. So run this. Okay. And look at my results. I got the object, the description, and the year. Object, description, year. Object, description, year. So what it did, again, see if I can get it. was it looped through the entire array of people, and for the first argument it gave us the object name, the description name, and the year, whatever year I assigned to them. So in the next tutorial we're going to be going over this some more, but thank you for watching. Don't forget to subscribe, and I will see you next tutorial. So people, welcome to your 45th Java tutorial, and in this tutorial I'm going to show you guys how to get a range of constants. Now this is going to be about 8 times as easier than the last tutorial, so just suck it up, pay attention, and I try to make it interesting for you. So since we need a range of constants and we only have 3 right here, it's not going to be very exciting, first of all. And what kind of range can we get with 3? So let's add a couple more of my ex-girlfriends to the list. I had one girlfriend named Nicole, and let's find a description word for her. She was Italian, and I dated her when I was, I don't know, probably like 13. So I'm gonna put 13, and don't want that semicolon. And my next girlfriend after this, I would have to say, is Candy. This is when I moved to my new school. She was my first girlfriend, and let's say she was let's put this nice, she was different. And let's see, how I was in 8th grade, so what's that, 14? Maybe I'm wrong, but we don't have time to think, we just have time to do. And let's see, after Candy, I got one in 9th grade, but what's the fun in that? There's this girl named Erin I had a huge crush on, but I never went out with her. But you know what, I'm gonna add her to my list because I wish I went out with her. So I'm gonna put I wish, because she's like the one that got away, and I had to be like 16 by the time. I had a crush on her for a long time. Erin, what could have been? Oh, anyways, so now we have a longer list of constants right here. So what we can do now is go back in our main method right here, and we'll just keep this one right here. This is what we did in the last tutorial, but let's see. Let's go ahead and make a new line under this for loop. I mean, we might as well keep this for loop. It's not hurting anything. And in case you're just joining us, this for loop pretty much printed out a list of all the constants. So let's go ahead and just print out a line so we can separate this for loop from our other for loop. So system out, did I spell system right? System out, print line. And let's just go ahead and print something like new line. Whoa, what's going on up in here? Alright, let's just put, and now for the range, I hit caps locks, embarrassing, of constants. So now we pretty much got this for loop right here, and we just got a line saying, and now for the range of constants. So, well, we just want to be able to see it easier. So now let's get to the meat of the tutorial, and this is an enhanced for loop to go through the range instead of the entire thing. So the first thing that we're going to need to do is at the beginning of our class, before our class, we need to import something. We need to import the enumSet class. So java.util.enum, enumset. And what this is going to do is it's going to allow us to use a built-in method called range to, well, you'll see what it does later. I mean, it's the best way to learn, right? Just to see. So let's go ahead and build our enhanced for loop now, just like last time. It's going to take 2 parameters. The first one is what you want to name your things. I'm just going to name them people, what you want to name your objects. Now the second one is that method. Now we could just plug a regular array in here, but we want to have a range of the array. We want it to start at, let's say, Kelsey, and we want it to end at Candy. So, I mean, we can start and end anywhere. So, whenever, like I said before, Java automatically gives you an array of constants in the order that you did them in. But in order to get just a specific set out of there, or range, what you need to do is this. enumSet period range, and the range is the method, and it takes 2 parameters. From is the first one, so let's just go ahead and write tuna, which is the class, Kelsey, and what's going to do is look at tuna class and find this first constant Kelsey, and that's going to be your starting point. And for 2, let's just put tuna.candy. And let's just go ahead and show. So now we have Kelsey to Candy and everything included. That's what that does. It gives you a whole new array. So now once we have that, we can pretty much just copy what we have up here. Copy. Thank you for that. And we'll paste that out here. And so now instead of an entire array which was tuna values, we have a specific set in the array which goes from all the constants from Kelsey to Candy. So now let me run this and see what we got. Let me I won't expand it. What's the fun in that? So now we have our first array right here that has all the information Bucky to Aaron. That was the entire array. And then we says our line, and then we goes, and now for the range of constants, and we cut out Kelsey, Julia, Nicole, and Candy. So using our enum set class and the method in that called range, we were able to provide it with two arguments, where we wanted to start and where we wanted to end. And this entire thing right here, it gave us a new array. So instead of looping through the old array, we're able to loop through this new and improved array to get only a specific set of data. So that is your quick tutorial on my former love life, and also how to loop through a specific range of an array using this range method right here. And again, don't forget to import this class or else you're not going to be able to use it. So thank you guys for watching. Now you know all about enumerations, constants, and how to loop through them and all and whatnot. I know, how exciting, right? So in the next tutorial, I don't know what we're going to be talking about, but I promise it's going to be awesome. So you might want to subscribe, just a little hint. So thank you for watching, and I will see you next tutorial. What's up guys, welcome to your 46th Java tutorial. And in this tutorial I'm going to be going over what static variables are and how they're used. So usually whenever you have a class that has objects, each of the variables, each object has its own set of variables, like first name, and I can make an object called Bucky, and it would have its own first name Bucky, and I could have another object named Tommy, and it would have its own first name of Tommy. But sometimes you want all the objects to share a single variable. For example, if you're going to make members of a club and you're going to like have the club count how many members were in it, for example, if I was in the club, it would be 1. If Tommy was in the club, it would be, if me and Tommy were in the club, it would be 2. If me, Tommy, and Megan were in the club, it will be 3. And we each don't need to see that. We each don't need an updated variable or a separate variable for 3, since the members in the club is all the same. So, for example, there's some variables that you just can share, and you're saying, alright, why don't you just write a separate variable for each object and update it? Well, that takes a lot of time and space. So you'll see what static is by the end of this tutorial, and it's one of the most useful things that I actually taught you so far, so listen up. In this tutorial we're going to be building a club, of course, and the club is going to be of hot girls that I would like to go out with. And yes, they will be famous, and no, I will never go out with them. So let's go ahead and make a couple regular variables first. For each object, it gets its own private string, and let's go ahead and put like first for first name, and then go ahead and put private string and last for last name. And now we need to give them a variable that they can share. So go ahead and put private and put static, and that static keyword means that every object shares the same variable. So when this one changes, it changes to all objects. And before, if you change one object's first name, that only that object's first name changed. But when you change a static variable, they change with all objects. So if I change this to 4, then all objects would see 4. Got it? Good. So static int, and we'll have members of our club, and we'll initialize the 0. So without building anything, we have 0 members in our club. So next, let's go ahead and make our constructor. So public, our class name is tuna, and it's going to take 2 arguments, string first name and string last name. This is how we're going to insert members into our club. And in our constructor, just put first equals first name, last equals last name, and let's just go ahead and put something like members plus plus. So each time we add a member, it adds 1 to our members variable. So after we add our first member, members will equal 1. When we add our second member, members will equal 2. So next, let's just go ahead and system out print format, and our format will be something like, again, you can be creative with this if you want, constructor for, make sure you spell it wrong, %s, so it'll be a constructor for Bucky Roberts, and then we'll have members in the club, and then put like colon %d, and then a new line. So we're going to have like constructor for Megan Fox, members in the club 1. Constructor for Natalie Portman, members in the club 2. Easy enough. So now we need to put first, of course, last, and members. And I spelled that wrong. members, members. That's a pretty catchy tune. Alright, now let's go ahead and write some more methods that are going to come in handy. First, we need something to get their first name. So, public, actually, let me think about this. For this tutorial, I'm teaching you is constructors, right? So we probably don't even need these yet, but we sure do in the next tutorial. So let's go ahead and in this apples, and in our main function right here, let's go ahead and make some members. So let's go ahead and make member 1 tuna, because it's in tuna class, member 1, and we'll set it equal to new tuna, and of course it takes the arguments. Again, you can see what arguments it takes by this constructor over here, a first name and a last name. So the first name can be Megan, and the last name of girls I want to date club can be Fox. So now what we should have outputted on the screen is, well, might as well just do it. Constructor for Megan Fox, members in the club 1. Easy enough. So let's go ahead and make another one now. Tuna member 2, we'll make another object equals new tuna, and we'll have something like Natalie and then Portman. You don't know who she is? Definitely Google it. And let's go ahead and make one more for fun. Tuna member 3 equals new tuna, and let's see, let's get Taylor, she can join the club too, and Swift, she is a babe with a pretty voice, hottie with body, cutie with booty. Anyways, so we made 3 different objects. Each one, well, let me run this, show you guys that it works, show myself that it works. So we made 3 different objects right here. One for Megan Fox named member 1, one for Natalie Portman named member 2, and one for Taylor named member 3. Each of them has their own set of variables. Let's look at this one, Natalie Portman, member number 2. For every object, they have their own set of variables right here. Natalie has her own first name right here, and she has her own last name of Portman right here, but they all share this members variable, and they can, like Megan Fox, this object, she can't see what Natalie's names are, but she can see the members in the club has changed it too. And when Taylor Swift joins the club right here, since it's static, it means all of these objects share the same static variable, so they can all see that the members of the club has changed to 3. So that's why static variables are useful, since, you know, sometimes you just need, and again, if you didn't have this on a new train of thought right here, you would have to have a function to update all of these each time. But, you know, why update 3 separate things, 1, 2, 3, and then when a member leaves, you'd have to update 3 separate things, 1, 2, 3, when you can just have one variable, call it static, and update it one time. So that's your quick tutorial on what static is and why it's useful. It pretty much, instead of having to update it many times, you just call it static, and all members or objects can see it. So thank you guys for watching this tutorial. If you don't understand, you will in the next tutorial, because we're going to be going over static some more. But like I said, thank you for watching. Don't forget to subscribe, and I will see you next time. What's up, guys? Welcome to your 47th Java tutorial, and in this tutorial I'm going to be finishing up talking about static members, and also I'm going to be showing you a nice little trick that you can use when accessing static members. So go ahead and in your tune class, or not the class with not your main method in it, class without your main method in, there we go. And let's go ahead and under this constructor, let's go ahead and build 3 other simple little methods. We're just going to have one to return the first name, return the last name, and return the member. So public string, and let's just name it like get first. It's not going to take any parameters, and we're just going to have it return first. Simple enough. And now let's go ahead and make one for last name. Public string get last, and guess what we're going to have this one too? Return last. Oh, you guessed that? Oh, not bad. And now let's have one more, and we'll name it let's see, public static. Remember, this method needs to be static. Static int get members. I know I could figure out how to spell members. Get members. And then what are we going to have this one do? Let's just have return members. So now we have 3 variables up here: a private first, a private last, and a private members, which is static. This method returns first name, this method returns the last name, and this method right here, it's going to return the variable members. So now that we have 3 objects made, go back in your main apples class or whatever you call it. Let's go ahead and let me show you how each member has its own set of data. So let's just go ahead and for housekeeping's sake put system out print line, and let's just go ahead and print an empty line right there because it'll just be easier. Now let's just go ahead and copy that because we're going to be using it. Oh, I didn't know we could do that, did we? And let's just go ahead and put, what do we want to print on our first line? And it's really our first line because this one's just an empty line. Well, what I want to show you that is, even though they all share that variable called members, they each have their own set of data. So let's go ahead and put member1, which is our object 1, which was Megan Fox, and we'll put get first, and then let's do this with last. Copy, get last, and what was the last one called? Get members. So get members. So here's what's going on now. Let me make sure it's going to print out. Yep. So anytime you call this one, it's going to have Megan Fox, and this is unique to its own object. But it's going to look at get members and see that it's static. So it's going to share this variable with all the other ones. So depending on how many members are in this, then that's what it's going to print. So let me go ahead and run this. Click OK, and we have, again, we have our other data up there if you're wondering where it went. But it says Megan, which is unique, Fox, which is unique, and 3, which is shared among all objects. So now let's go ahead and change that to 2. Member 2, member 2, member 2. Now let's go ahead and run this, and now you can clearly see Natalie, which is unique, Portman, which is unique, and 3, again, that 3. And that 3 is because this private static int. Static means, alright, this variable is shared between all objects. So we don't need to, why would you make a separate variable if it, like, let me think how to put this. Why would you make a separate variable that is going to be unique that we're going to have to update in every object if it's the same value no matter what object it is? So, I mean, you don't need to. So we're not gonna. So that's where static comes in handy. And now let me show you that trick I was talking about. Since the static variables don't change between objects, static information is available even when you don't have an object. So for example, say forget about all of these objects right here, and we actually can't just delete them, but we'll delete these right here, and we can just add it in this print line. Really, instead of calling a separate object like an object and then your dot separator and then your method like that, What you can do with stack is just put the name of the class and put your dot separator and then put your method get members, like that. Now let me run this and you can see the 3 right here. Can you guys see that? The 3 right there. So before, we were never able to do this. We had to get an object and build an object anytime we wanted access to any of these members or any of these methods right here. But with a static, it's a little bit different because it's not going to change from object to object, since no matter how many objects you have, the variable is the same. So that's why Java lets you, instead of having to have an object, which you can do by the way, what we just did, you can also just put the class name and put the static method ahead of that. So again, anytime you have a static method that uses static variables, you don't have to have a separate object. You can just put the class name and then you can just put the method. And that's how, like in stuff like math functions and math constants, that's how they do that. So that's just a nice little tidbit of information. So don't forget that static variables are shared among all objects, and that you don't have to access static methods with a specific object. You can just do it with a whole class, since it's the same. So thank you guys for watching. I think I confused you enough for today, but like I said, thank you for watching. Don't forget to subscribe, and I will see you next tutorial. What's up YouTube? Welcome to your 48th Java tutorial, and in this tutorial we're going to be going over instance variables with the final, like when you have like public final or private final int. That's what we're going to be going over. So unlike static, I'm going to be showing you guys what final means. So let's go ahead and in your tuna class right here, and this is the one that's not your main. Apples has my main method, so go into another one. I name mine tuna. You can name yours whatever you want as long as it's a fish. That's key. It has to be fish or this program won't work. I'm just kidding, but you know, just a little joke. And let's go ahead, and the first thing we're going to want to do is make a variable that's going to be private as well, but you got to spell it right. That's the key. Private. There we go. I know I'd get it eventually. Int sum. And what this is going to do is hold the sum of our numbers that we're about to add up. Now let's begin the tutorial. What we want to do now is make a variable with the type final. So private final, and it's going to be an integer variable, and I hit button there. Embarrassing. And let's just name it number or something. And go ahead and put it in caps because it's going to be a constant, so we know that the constants are in caps. K. There you go. K. That's how you can remember it. So now the key, or what final is whenever you write final in front of a variable or a constant, it means that you can't modify this no matter what. So we just declared it. Whenever we set it equal to something, whatever we set it equal to, we can only set it equal to it once. So if we put number equals 2, then that number is going to be 2 for the rest of your life. You can't change it no matter what. But another thing is we declared it right there, but we didn't initialize it, which means we didn't set it equal to anything. So we're going to have to do that in our constructor. So again, you can either do it right here or you're in your constructor. So let's go ahead and make a constructor. Put public tuna and just put int x. This is going to be a temporary variable, and then put number equal to x. So whatever we pass in for our argument, that's what number is going to be equal to. And again, don't mess it up because you can't change this. You can't later in your program write, alright, we're set it equal to 2 here, but we're going to set it equal to 15 later on, or 18, or 32. You can't. You can only set it equal to something here, and it stays like that forever. Now let's go ahead and build another method. So let's go ahead and write public void, make it called add, because what's it going to do, it's going to take that sum that we have up here, and it's going to be 0 default, and let's just add the number to it. So again, the sum variable is going to change, but this number is always going to be like 10 or whatever we say it is. And now let's just build one more method so we can actually see what's going on. Public string to string, So again, you learned what toString method did last time. Whenever you need your object in a string format, it returns it. So let's go ahead and return string format, and it already started filling out for us. The format's just going to be, put something like sum is equal to %d, and then put like a new line for good looks. And then for your arguments, just put sum. So this is going to change because it's the number that stays the same and not the sum. And how do we know that? Because number variable is final and sum is just private. Sum can change. So now that we got that, look it over and make sure it's the exact same as mine. We can go to our main class, which is apples in this case. So go ahead and let's create an object. So tuna object equals new tuna, and let's go ahead and put something like 10. So now what this is going to do, since we passed in 10 to our constructor, it's going to take 10 for x, put 10 for x right here, and set number equal to 10. So now for this object, number equals 10 no matter what. We can't change that. So anytime we use number, like add number to sum, we add 10 to sum. Simple enough. So now let's go ahead and make a for loop using this object. So let's just put for, and let's make a simple loop. Put like int I equals 0, if I is less than 5, and I plus plus. So it loops 5 times. 1, 2, 3, 4. Yep, loops 5 times. It really doesn't matter what you have inside your for loop. This isn't important. Just had to make something real quick. Now we can go ahead and say, what do we want to do 5 times? Well, let's go ahead and add, let's call this method 5 times. So the first time it's going to be 10 when it adds it. The second time it's going to add another 10 to it, so it's going to be 20. Then it's going to be 30, 40, 50. Simple enough. So let's go ahead and add tuna object, and how you use it is add right there. So now we did our method 5 times, but we can't really see anything because this method right here, it doesn't return anything, so we need to return it right here. So let's go ahead and put system out. Let's go ahead and let's do a print format, and let's just go ahead for the format. We'll put something like, let's keep it simple, %s, and for the arguments, let's just go ahead and put tuna object. So let me go ahead and run through this and show you guys the results. Sum equals 10, sum equals 20, 30, 40, 50. So now let me talk to you guys one last time why this happened. Make sure, hopefully I'm in my screen recorder. Good enough. So what we did is we made 2 variables. Well, let's just go ahead and do it this way. We made an object called new tuna, or tuna object was the name of our object, and we passed it the parameters 10 for the constructor. So it took that 10 and set number equal to 10. Alright, simple enough. What's next? Well, we looped through this 5 times. So what did we do 5 times? We did this add method 5 times. So first, for add, it took that number 10 and added it to sum. So now sum was equal to 10. Then it just spit out 10. And then the next time, on round number 2, it took that 10 and added it to 10. Then we got 20. So now it spit it out 20. Then it took 10 and added it to 20, which was 30. Then it added it to 30, which was 40. Then it added it to 40, which was 50. So now that that's all done, so that is pretty much your really detailed tutorial on a really simple explanation that whenever you make a final variable, you cannot change it. So for example, if we say down here tuna object dot number equals 15, look at this right here, we get an X right here. The field tuna number is not visible. That means that it can't change pretty much. So that's pretty much all in all. I could have skipped this whole tutorial and said, alright, when you write final instead of a variable, it means you can't change it, but I didn't. I decided to give you guys the whole spiel instead. So thank you guys for watching, and hey, if anyone wants to do fantasy football with me, leave a comment and let me know, because I want to do fantasy football with someone. So thank you guys for watching, and don't forget to subscribe, and I'll see you next time. What's up guys, welcome to your 49th Java tutorial, and in this tutorial I'm going to be talking about inheritance. Now what inheritance is pretty much inheriting stuff from another class. So why is this useful? Well, say we have two classes right here, tuna and pot pie, and in the tuna class we have a method like public void, we'll just name it eat. And let's say in this method all it does is go system out print line, and then it just prints something like I am the eat method. And say if we had a bunch of different little food classes, and every single food class had this method. So tuna had it, and pot pie had it, and say we had a bunch of other ones like chicken, liver, ham. They all had the same exact eat method. So then your boss comes in and tells you, alright, you know when you wrote the eat method and said I'm the eat method? Well, we actually want you to say I am the eat methods with a S. So now you gotta go in every single different class and change that one method and add a S on the end. And you're saying, alright, I wish instead of having all these copies that I would have to maintain, if I could just have one single copy. So that's what exactly inheritance is. Instead of having all these copies in different classes that you have to maintain, you can only have one single copy that you have to maintain, and each of these classes can inherit that. So let's go ahead and copy this, and since tuna and pot pie are both foods, I made this new food class right here. And what this food class is going to do is it's going to store all the things that tuna and pot pie have in common. And right now they have this eat method in common. So we can go ahead and get rid of this method right here and get rid of this method in here. And instead of having all these separate methods and all these classes, we only have to maintain this one method in the food class. So how exactly does this work, and how can we only have one method to kind of take care of? Well, this is what inheritance is. Instead of having a bunch of different methods, what this tuna class and pot pie class can do is it inherits everything, the variables and methods, from this main food class. And whenever we do this, the kind of methods that inherit the stuff, those are called the subclasses, and the stuff that they, or the class that they inherit from, is called the superclass. So again, these two tuna and pot pie classes are going to inherit all the stuff that's in the food class, and the food class is called the superclass, and the tuna and pot pie class are called the subclasses. So how exactly do we inherit everything? Well, instead of say inherit from, what Java said is it gives it a new keyword named extends, EXTENDS. And whenever you write extends, this means inherit from. So if you say public class pot pie extends food, this means alright, in this class pot pie we're going to inherit everything from food. So we're going to inherit any variable that would be inherent in all the methods. So let's go ahead and do that same thing from tuna. So public class tuna, this class EXTENDS, it extends food. So now anything that's in food is inside pot pie and tuna. Even though we can't see it, that's what we mean. So let's go ahead and let me show you guys that right now. So say we go, or wherever your main method is right here, let's go ahead and make an object. So I'm going to make my tuna object, and let's just go ahead and put new tuna. Let's just go ahead and make the same thing with pot pie. So pot pie, pot object, JCT, I know I figure it out eventually, new pot pie. So now we have a tuna object and a pot pie object. Make sure I didn't mess anything up. So now, even though we have no methods in here, they inherited all the methods from food. So we would use those methods just like we would anyone else. So this method is called eat, don't remember, and it's in pot pie and tuna, even though you can't see it. So let's go ahead and put tuna object.eat and pot pie, or what's it called, pot object.eat, and see what happens. And we're getting a error right here. Oh, we forgot an equal sign. There we go. And now when we run this, we see I am the eat methods, and this one came from tuna, and this one came from pot object. So that's how you can inherit all the methods from another class using the extends keyword. But what if you're saying, alright, you know, I have a bunch of different foods, and I know we only have 2 foods right now. This is just to demonstrate, but you're saying, alright, I have a bunch of different foods like tuna, pot pie, chicken liver, but I have this one class called tuna, and I want to inherit all the stuff from food, but I want to change this one method right here. Well, what you can do is override certain methods, and in order to override certain methods, you just put the method into the class, the subclass, and you recreate it. So then, if you say, alright, I am the new method of tuna. So make sure you spell a couple things wrong there. And now, whenever you override something, you inherit everything from the food class, but the methods that you recreate, they're going to override or overpower the methods that you inherited. So now, if we go ahead and run this, we see this. Let me get it up for you. There we go. I am the new method of tuna, and this is the method that we overrode. And again, it's the easiest thing in the world. Whenever you want to override something, all you have to do is pretty much just create it again. And then you don't have to worry about, you know, well, it's pretty much as simple as that. I can't explain it any better. But that's how you override something. In pot objects, we didn't override that method, so that's why it got the default food method. And the last thing, or the last couple things I want to talk about real quick, if, say, tuna extends pot pie, and pot pie extends food, then tuna inherits all the stuff from pot pie and food. It's like a little hierarchy. So let's go ahead and delete this. And now, when tuna extends pot pie, it inherits all the stuff from pot pie and food. And the last thing I want to take note of is that only, let's go ahead and get rid of one of these objects. Let's go ahead and get rid of the pot object. Only the public methods can be inherited. Let me see how much time I got left. 2 minutes. Only public methods can be inherited. So if you have a private method in the superclass, again, the superclass is the one that the subclass inherits from, and we want to change that to food. So right now, tuna is inheriting all the stuff from food, but food has this method in here that's private. What private means is, alright, you can't inherit this from me. In order to inherit it, it needs to be public like we did before. But when we put private like this and try to run this right here, we get a little error right here, and it says the method eat is not visible. So whenever we try to run it, I'll show you the syntax error down here. And then pretty much this is saying, alright, this isn't visible because food has a private thing that you try to inherit and use, and you can't. It's private, it's not public. So that's your real quick tutorial on inheritance. And pretty much anytime you want to inherit crap from another class, just write extends. And extends is just a real fancy word for tuna inherits from food, or tuna inherits all the methods and variables from food. And again, well, that's it for this tutorial. I already filled your brain with enough. So that's your real quick tutorial on inheritance. I hope I made it simple. I hope you guys can understand. So thank you guys for watching, and I will see you in the next tutorial. What is going on, people? Welcome to your 50th Java tutorial. And I know it's been a while since I started making Java tutorials, but hey, we're going to get back on track and start learning some more Java. So actually I had planned out that we're going to learn polymorphism, but I think I'm just going to skip right to GUIs because it's a lot funner, and it's better if we know how to make an interface before we start getting into some other stuff. Plus, when we have an interface and stuff, you can see what everything does. and you're not just typing random code that you're like, alright, what is this, the Matrix? Because it's time we started building an application that the user can interact with and see. So if you don't know what a GUI is, or some people call it a GUI, it's a graphical user interface. And just like this right here, it has a title bar at the top, menu, drop downs, it has a whole different range of buttons, and that's what we're going to be making instead of this right here where it's like the Matrix style, because I mean, come on, it's 2009. If you're watching this tutorial in 2009, that is. So let's go ahead and get started. Now the first thing you need to know is that all GUIs are built from GUI or GUI components. That means there has to be a component for a menu, a dialog box, scroll bars. You have to add each one of those individually. So how do you just go ahead and get these components? Well, actually, Java has a built-in class that stores all the components you need. You just need to tell it where to put it and what to do with it. And they are created using different methods. And the methods you use to create this in the class is called the JOptionPane class. Now, like I said, this class is built into Java. So anytime you want to make a button, all you need to do is call it from the class. And there are different ways to do this, but this is the easiest way. So in order to get all those buttons and toolbars and everything, we first need to import the entire class. So let's go ahead and before your even class right here, just go ahead and put import javax dot swing dot j option pane, and make sure you type the J and the O capital option pane, and just like that. And now we're getting a little error that says the import Java JOptionPane is never used. So let's go ahead and fix that by using some stuff right now. So now we imported the class, which means we have access to all the crap in it. So let's start using some of that crap. The first thing we're going to want to do is set two variables. By the way, I'm going to build a program where you enter a number in one box and then click OK, you enter a number in another, click OK, and the end box, the third one, shows your answer. You'll see in a little bit. So we need to set this equal to a string variable and set it equal to first number, and I'm just going to write fn, or excuse me, fn for first number. Now what you need to do is call the class, which is JOptionPane, use your period or dot separator, and the method for an input dialog is show input, if you couldn't tell by these 100 pop-up things that pop up, dialog. And it's going to take one parameter right here, and this is the message. Now what this is the message or the prompt which you want to tell the user to do. So we just want to put in a string, enter first number. So now whatever they enter into that first number is going to be stored in the variable fn. So now we need a second number, so let's go ahead and copy this, press enter, paste it, and let's just set string second number, and we'll just put enter second number right there. Make sure I got my whatever it's called, semicolon, and let's go ahead and move this over here because just because I feel like it. Now here's a little thing that you need to know. Every time they enter something in here, show input dialog method only is able to get a string. So we can't add strings. Strings are pretty much letters and numbers that it doesn't see as a number. So we need to tell Java, alright, instead of viewing this as a string, we want you to view it as an integer so you can do some math with it later on. So what we need to do is convert these variables to integers. So this has nothing to do with JOptionPane. This is just Java right here. So Java int num1 equals integer dot parse int, and what this does is convert whatever I type into here and stores it as an integer in num1. So I want to put fn, and what this does is take the string, which say it's 5, and converts it into the number 5. So now let's go ahead and do this for num2. We want to take the second number we typed in and convert it to a variable called number2. So now the last thing we need to do is just show the sum. So before we even do that, let's just add the sum. Int sum equals what do we put? num1 plus num2, no spaces. And now we got the final answer in the sum variable right here. Let's tighten that up a little bit. That's what she said. And now we can go ahead and display this. Now the box that you use to display is something called show message dialog. So let's put J option pane dot show message dialog. And this is a little different than show input dialog. Inputs for inputting, messages for displaying. Now this method takes 4 parameters. The first one is it's a parameter where to position it, and if you put null, it positions it right in the middle of the screen. The second one is what you want to say, like for your prompt, but it isn't prompt, it's just a message. So let's put the answer is, and let's just put add sum. So it's going to be like the answer is 5 or something like that. Now the third parameter is what you want to appear on your title bar. So let's put like the title or something easy like that. And the fourth parameter you need is the message that's going to pop up. Now I'll go over this later if I got time, but for right now just put J option was it pane, then put plain underscore message, like that. And you don't need to put this last thing in quotation marks. So again, well, that's pretty much it. Let's just go ahead and run this program. I'm tired of waiting around. So let's go ahead, click OK, run it. Enter your first number, 3. Okay. Enter your second number, 5. Okay. The answer is 8. And now I can talk you through this one more time. So now once we go ahead and run this, what we're getting is this very first thing, the show input dialog, and it says enter your first number, and we're going to go ahead and enter 4, press OK. Now once we press OK, it stores that 4 in fn variable right there, and also it allows us to move on to this other show input dialog. It doesn't move on until you complete the show input dialog. So enter your second number, 6. OK. So now what it did right here is it took that 4 and converted it to a number, and took that 6 and converted it to a number, so that you can add the 2 sums right here. And lastly, it took that show message dialog, which if I can get it back right here, and it says that null, which means position in the center of our screen. The answer is sum right here, and again that third parameter was the title, which appeared on the title bar. And that last one, you have the option of putting icons on your GUI or user interface that we built, but we're not going to put icons on here now, mostly because they're stupid. If you want to have something like an error, you can put X on there, a warning, you put like a, I don't know, they're stupid, but we'll probably put them in next time because I'm stupid too. So but that's a real quick tutorial on how to use J option pane to make a simple graphical user interface, aka GUI. So in the next tutorial we're going to be building our GUIs and adding some more function, add some more cool buttons and stuff like that. So thank you guys for watching. Don't forget to subscribe, and I will see you next tutorial. What is going on, people? Welcome to your 52nd Java tutorial. And this tutorial is probably going to be pretty long. It's probably going to be a multi-part tutorial, and we're going to be talking about event handlers. So what an event handler or event handling is in the last tutorial I showed you guys how to build a simple GUI or GUI. Well, what an event is anything that the user can do, like move their mouse, click a button, press enter. Those are called events in computer language. Now what an event handler is the code that responds to your mouse movement or button clicking. So the event would be click a button. The event handler would be the code that says, okay, when you click this, I want another box to pop up that says you just clicked the button or something like that. So the event is what the user does. The event handler is what the programmer makes when they do that event. And this overall process is called event handling. So I'll be talking about this later on, but you guys need to know pretty much. I just want to tell you, in this program or tutorial, we're going to be building a window on the screen, and we're going to be building some text boxes inside that window, and whenever the user enters text and press enter, the event handler is going to say, alright, I'm going to pop up another box. So let's just go ahead and get started. If you don't know what I'm talking about, then you'll figure it out eventually. Okay, I need a little break now. The first thing we need to do is import a bunch of crap that we're going to use in this tutorial. So I'm going to go ahead and type import java.awt.flow layout, and make sure your A is not capitalized, and go ahead and you can just copy this right here because we're going to be using something similar to it. So we imported Java AWT flow layout. The next thing we want to import is java.awt.event.action listener. Let me make sure I spelled listener right. Yep. And what this does, flow layout pretty much gives you layout. The listener listens or pretty much waits for the user to do something like press enter or something. So now the last thing we need to import from the AWT is event. Come on, cursor. Seriously? AWT.event.action event. And these are events which I told you about last time. Now we need to import 4 things from the swing. So let's go ahead and import JavaX. Make sure you have the X swing.jFrame. And now we can go ahead and, well, might as well copy that because we're going to import 3 other things. Copy, paste, paste, paste. We need to import JFrame, JTextField, and make sure that you got your capitalization same as mine with a T and the F capitalized. JFrame, JTextField, JPassword field. And text field is somewhere where you can type text. Password is the same thing, but instead of showing the text, it covers it up in asterisks so you can't see. And the last thing is option pane. So now we imported everything that we need for this tutorial, and these pretty much are all the built-in methods and variables that we're going to use. So now what we need to do for our tuna class is, just like before, we need to extend or inherit all the stuff from JFrame. And what this pretty much does is give us all, it pretty much lets us use a window. So now we created a window like any other program. Now we can start putting stuff in it. So we're going to put 3 items plus a password field in it, or pretty much 4 text fields. So let's go ahead and make variables for those. Let's make our first text field first. So private J text field, and you need to put J text field, and you can name it anything you want. I'm just going to name my item 1, and I'm going to make 3 of these, so I'm just going to copy this because I am extremely lazy. Item 2 and item 3. And the last, sorry about that, I had to take a little break, help my roommate find his phone, but alright. So we created 3 text fields right here. Now let's go ahead and create our last password field, and we'll set that to private as well because, I mean, why not? J password field, like that. And let's just give this a variable, oops, password field. Looks good. So now I did something, oh, no semicolon, embarrassing. So we created 3 items plus a password field. Now let's go ahead and create our window. So let's go ahead and create a constructor for this, and since my class is named Tuna, I'm going to have to create a method that's named Tuna. So I'm just going ahead and going to type public Tuna, doesn't take any arguments, and whatever I create in this is pretty much the window. So the first thing I need to do, or first thing I actually want to do, is add a title to this. And if you remember from the last tutorial, to do this you just put super, and then in your argument you put the title or whatever you want for the title. Not going to get anything fancy because I'm not creative at all. So now we're going to have to set the layout for this, which is pretty much how things are placed. And we don't want to have to code a new layout and place everything, so we're just going to grab a one by default. And how you do this, put set layout, and if you're wondering where all these methods are coming from, they're imported somewhere up here, all these built-in methods that I'm using. You just can't make set layout and put it in everything. You actually have to import it. So set layout takes one argument, and the argument for this is new flow layout, just like that. And that is a method in itself, so make sure you have that typed just like that. So now we have a title and a layout to our window, so let's go ahead and start adding those text fields right there. So the first thing we're going to add is the item 1, and we're going to set this equal to new J text field. And in the parameters for this, set the length of it as 10. And now we have an item, but we didn't add it to the window yet. So let's go ahead and add item 1, and this will add the item to our window. So now, although you can't see it, you pretty much have a blank window with just a little text field on the screen. Now we're going to go ahead and do that for the rest of our items. So let's go ahead and put item 2 and set this one equal to, and these are going to be a little bit different, just change things up a little bit. New J text field, but as your parameters, go ahead for this one and put like enter text here. Now what this is going to do is give you default text inside, and it pretty much is like a prompt. Now let's go ahead and add this one to the screen, item 2. So now we have pretty much an empty window with two things on our screen, two text fields. So now let's go ahead and change our item 3 variable to, yeah, you guessed it, new J text field. And for this one we'll go ahead and type, alright, let me think of something to do. There we go. Let's go ahead and type, we'll make this text uneditable, and we'll give it a default value of 20. And now we have a text field that says uneditable in it, and we want to make sure that the user cannot edit this. So what we're going to do is take that item 3, which is that text field, and how you set the editableness is go set editable, and what you're going to do for this is put false. And if you put false in that text field is not going to be editable, so the user is going to be able to change what's on the screen, read what's on the screen, but they aren't going to be able to edit it. And now what we want to do is just add item number 3 to that, and the last thing we're going to make is our password field. So just go ahead and write password field, and we're going to set this equal to new J, let me get it, password field. Make sure I typed everything right, and as a default you can give get out of there, my pass or something, and this is going to show up in asterisk on your screen. So now that we have that, we can just go ahead and add the password field. Oh, don't want that. So now we have a screen with 4 things on it. We have 4 different text boxes, and each one of them is a little different. I just want to show you guys that changing the parameters does a little thing different to it, and you'll see this later on visually. But in the next tutorial we're actually going to be adding an event and handlers to this. That means when you enter text and press enter, do this or do that. But for now I just wanted to get our window set up, and in the next tutorial we're going to start programming this baby. So I cannot wait. Thank you guys for watching, and I'll see you next time. What is going on, guys? Welcome to your 53rd Java tutorial, and this is pretty much a continuation of the 52nd one, and there's probably going to be a 54th one. But just a real quick review, what we did is pretty much already, if you didn't watch 52 for some reason, we just built a window and put 4 things in it. And that's pretty much it. And now what we're going to do is pretty much add some functionality to this. And what we're going to say is, alright, when you enter text in one of those text fields and press enter, what we want to do is pop up another box saying what you entered. Like when a user would type in something and it says like a verification or something. So let's get right to it. Now, what we need to do is, the first thing that we're going to need to do is build an action listener object. So what this means is we have 4 text fields waiting on the screen, and they're pretty much dumb and they don't do anything right now. What we want them to do is to add some brains to them and have them waiting on the screen and listening, it's called. And when you listen, you're pretty much just waiting for an event to happen. So right now they just look pretty, they're not even waiting for anything. So what we want to say is, alright, text boxes, listen for something to happen, and when that happens we want you to execute a bunch of code. So the first thing that we're going to need to do is we're going to build another class to execute the code, but this class, I'm going to build an object for this class before I even build the class. So the class name is going to be the handler, and we're going to get some errors right here, but that's fine. And I'm just going to name my object handler, and this is going to be equals new handler class. And if you're saying, alright, where is this handler class? We didn't build it yet, but I will, we promise. So actually, hold on, new the handler, there we go. And what this does is it pretty much builds an action listener object. So now we're gonna make a new class later on that you'll see what this does later. But what we need to do is add this object to each of the items. So item 1, what we need to do is add action listener, and what this takes as an argument is the object we just created, so that's why we need to do that. And the object, you can see, is called handler, so handler, right like that. And we need to do this for each object, so let's go ahead and copy this, copy and paste item 2, item 3, and of course our password, which is password field right there, and add action listener, and this is of course going to take the handler argument again. So now we have an object of the class the handler, which we didn't make yet, but that's what we're going to do right now. So once you let me make sure, here's JFrame, here's the one class, here's where one class ends, or pretty much our constructor. And now here's another thing I'm going to tell you. This pretty much whole thing is our constructor, which is pretty much a method for this tuna class. And you're probably thinking, alright, I'm going to build a new class, I'm going to build it on the outside of this. Well, actually, we're going to build another class, but we're going to build it inside this tuna class. And when you do that, when you build a class inside a class, the class that's inside inherits all the crap from the class that's outside. So that's what we want to do. So let's go ahead and make this private because it's no need to make it public. Class, and I hit insert, class the handler, or whatever you named it right there. And now we see we get a whole bunch of other error messages. Implements action listener, and I spelled there we go, implements action listener. Now what we want to do is go ahead and build a body for this, and now what we have is our class. And why did we need to name it the handler? Because that's what the object was. And it implements action listener, and what this means is pretty much that this is going to be the class to handle the events, and you'll see why later on, but I know it's confusing right now. But what this action listener class is it takes one method. There's only one method we're going to be building in this class, and that's the method that's going to be called automatically whenever an event occurs. And to do that, type public void, and I know this doesn't make any sense to you right now. It's weird because you kind of have to build the whole program to see what's going on, but I promise by the end of this you'll see what's going on. Action, and you need to name this performed, and as a argument you need to take action event, and then you need to name your variable something like event, like that. And now, as well, let's go ahead and start building the body for this. So what happens in this private class right here is as soon as an event occurs, whatever happens inside here is going to handle the event. So let's go ahead and type some stuff to pretty much just add a body to our method. The first thing we're going to do is build a string variable, and we're just name it string and set it equal to an empty string. And this is going to be the final string that outputs, but you know, we don't need to worry about that now. Now the next thing we're going to want to do is make pretty much a huge if statement, and you'll see why in a second. The first condition we're going to test if the event, and remember this is like an enter or a click, and in this case it's going to be if the event is going to be when the I can't talk. When the user presses enter. So if the event equals get source, and the source pretty much means where it happens. If it's equal to item 1, and what this means is pretty much if they clicked enter on text field number 1, then what do we want to do? Well, the first thing we're going to want to do is take that string variable that is empty right now, and we want to set it equal to string format, and we would just use C style formatting, and we're going to want to set this equal to put something like field 1 %s, and put those in quotation marks. So what this is going to output is field 1 with a variable right here, and as our variable, what we want to do is put event, and this is get action command. Now this is the last thing in this tutorial that's going to confuse you. What get action command means, after I add my semicolon, is get the text from that location. So if they type in Bucky in field 1 and press enter, what this is going to do is say, alright, your event source, or you hit enter at item number 1. So what I'm going to do is put field 1 equals Bucky, and you'll see why later on. But for now, just follow with me. The next thing we're going to do is build 3 else ifs. So else if, and just go ahead and copy this, paste, in event 2, field 2, and we'll get the action command for that. Now let's go ahead and just copy this one more time. Copy. And make sure my cursor's in the right spot. Oh, cool, it's messing up. Cool. And paste. If event get sorts equals from item 3, then we just want to output field 3 equals that. And now what we want to do lastly is put else if, and let's go ahead and put event get source. Alright, if this event occurs on, what do we name it, password field, then what do you want to do? Set the string, why are you messing up, Haas? Set the string equal to string format, and let's just go ahead and do the same thing. The format is let's put password field is %s, and the arguments it takes is of course event get action command right there. So now let me make sure we're good to go. Don't have any errors aside from these. And what error are we getting right here? The method add action layer is undefined, which is we'll worry about that later. And the last thing we're going to want to do, actually I'm running out of time, so I'll do it in the next tutorial. In the next tutorial we will finish everything up. So thank you guys for watching, and I'll see you then. What is up, people? Welcome to your 54th and hopefully the last tutorial in this little 3-part series. And before I get started, I just want to tell you guys about one error that I did. I spelled listener wrong, like I always do, and just change that to T-E-N-E-R. And if you have more than 3rd grade education, you should know that, but I don't. So now we can go ahead and continue with the rest of our tutorial. So pretty much in this handling class, or the class that handles the event, what we did is we took a string variable and we set it equal to an empty string, or a string with nothing in it. And then we say, alright, if they type something into box number 1 and press enter, then we're going to say, alright, we're going to change that string to field 1 equals whatever you typed in. If they did it in field 2, field 3, or the password field, that's what we're going to do. So now all we pretty much did is we changed that string variable. So if they type Bucky for the string variable, this pretty much changes the string variable. And now the last thing we need to do in this class is pretty much output it on the screen somehow. So this is the last line, so don't worry. Just type J option pane, And why do we get to use this? Because we imported it up here at J option pane. And what this pretty much does is pretty much just a blank window. And what we're going to do is show message dialog. Make sure I didn't spell that wrong too. And it's going to take two parameters. The first parameter it takes is null. Don't worry about that. It has to do with positioning. And the second one it takes is your variable you want to output in that string. So now let me walk you guys through this one last time. We imported a bunch of stuff to use that's not important. The second thing we did is we pretty much built a window using JFrame, which we did in the last tutorial. You should know how we did that. Now here we get to the good stuff. What you definitely need in order to handle events is pretty much an event handling class that implements action listener, and we built that class right here. Now once we made that class, we can create objects for that class, and we created a class, or excuse me, an object named handler. So anytime that you use this object, it's going to refer to this class right here. And after we built this class and we built this object, we're going to go ahead and add that object to each one of these items. Now we gave each of these items some functionality. So before they were just sitting there, and now once you press enter on them, they actually do something. And what it does has to do with this method right here. Now inside your class that handles events, you need this method and you need to call it action performed. This is a built-in method that has to do with the action listener class. This method gets executed automatically whenever an event occurs. So the event that's occurred is enter. So whenever they press enter, what's going to happen is it's going to create an empty string. It's going to test what you're going to want to change that string to, and then it's going to output it right there. So this is all the hard stuff we did right here. So copy that and do exactly as I did. Now that we made all the hard stuff, we can go ahead and just execute it like we always do. So my main thing is called apples. You can do anything you want. The first thing we're going to need to import, and the only thing, so don't worry, import javax.swing.jframe, and this just makes sure that we can use Windows in our main method right here. So now let's go ahead and start calling our object. So let's go ahead and create a new object called Bucky or whatever, and my class was named Tuna. You can name or whatever you can name your object whatever you want, but make sure, well, you should know how to do this right now. Equals a new object from the class Tuna, and the second line we want to put is the close operation like we did before. So we're going to take that object, which is pretty much the thing we just created, that window, and set default, there we go, close operation. I was too lazy to type it all. And the argument that this is going to take, what's all this crap in my way, is jframe dot exit underscore on underscore close. And like before, this just means that whenever we hit X, we want to exit the program. Why they don't do it automatically, I don't know, but you need to do it yourself. The next thing we're going to want to do is set the size of the window, and we do this by setting the size, and we're just going to set this to something like 350 by 100. I feel like, what the heck was that? I just had like a piece of skin in my mouth or something. Pretty disgusting. By the way, I got something really disgusting to tell you next tutorial, or if I have time at the end of this tutorial. But it's a disgusting story that I heard the other day, so I'll tell you then. Last thing we need to do is set the visibility. So set visible. I need to learn how to spell. So, and we'll just set this to true. And now let me walk you guys through this one last time. So now make sure we don't have any errors anywhere, and go ahead and click OK, OK, and hopefully this works. And now here is what we built. Go ahead and type Bucky, press enter. It says field 1 equals Bucky. Enter text here. Go ahead and type Freddie. Field 2 equals Freddie. Uneditable. Look this. I'm typing, can't edit it, so go ahead and press enter in that, uneditable. And this password, by default, if you press enter, it's my pass, but you can go ahead and change that to something like that, and then it changes to GFGDS. So I'm going to talk you guys through this one last time how this works. If you don't want to listen to me, you can go ahead and watch my next tutorial, or watch some videos of like dogs doing silly things online. But for those of you guys who really want to figure out how this works, I'm going to tell you right now. Well, let's go ahead and just skip the good stuff right here. In order to handle events in Java, you need an event handling class, and that class needs to implement action listener. And what action listener allows you to do is put that listener on something, which means, alright, I'm gonna wait for an event to happen, and once it happens, I'm gonna do some code. And that, once we have this class, we can go ahead and create an object. And why do we need to create an object? Well, we need to create an object because this add action listener method, it takes an object as its argument. So that's why we needed to create an object. And the object it takes as the argument is how it wants to handle that event. So why can't it just automatically know what event to handle because of this class right here? Well, sometimes you have different events in different classes, so that's why. So now, once we have this class that handles the event and the object built, we can go ahead and add some functionality to this. So what this method does is get performed automatically whenever you call this class. It's kind of like a constructor, but kind of not. So, and what this does is take the event as the argument, which is in this case the pressing of the enter button. What this does is says, alright, if event get source, which means where the thing occurred, equals item 1 if it occurred in text box item number 1, then what we're going to do is set the string equal to whatever was inside that text box. If it occurred in item 2, set the string that was equal to in that text box. If it occurred in number 3, set the string equal to what was in that text box. 4, same thing. And now, once we set our string variable as something, depending on what was inside that text box, we're just going to output it in the J option pane, which was that little checkbox, that little box at the end that pretty much just said Greg or Bucky or whatever I typed in there. So that is your tutorial on how to handle events. I'm sorry it was really long, but it was also really necessary. So guys, I hope you understand pretty much the basics of what I did. We'll be going over this a little later, so if you don't, you'll probably figure it out. But thank you guys for watching. Thank you for supporting my channel, and for all the awesome comments and some of the not so awesome ones. But again, I thank all of you guys, all of the people who watch my videos. So I can't wait to do a next tutorial, so I'll see you then. What is going on, guys? Welcome to your 55th Java tutorial, and in this tutorial we're going to be getting into polymorphism a little bit, and also talking about or building something called a polymorphic array to demonstrate why polymorphism is actually useful. And it's a pretty confusing topic, and trust me, there are going to be a lot of tutorials on this. So if you're not quite sure what's going on by the end of this tutorial, then I promise you in a couple of tutorials you'll be a pro on polymorphism. So in order to demonstrate polymorphism, we first need to build a computer program that uses inheritance in one way or another. So what I did is I set up, and you can probably tell this if you watch my last tutorials, I'm going to have a superclass called food. In this tuna class and pot pie class, since they're both types of food, they're going to inherit all the methods and variables in this food class. So the food is a superclass, and the tuna and pot pie are subclasses. I already put extends food, and what extends food does is use an inheritance to inherit everything from food. But you should know that already if you watch my other tutorials. Just for the people who just started, that's what I'm doing. So now let's go ahead and build a basic method called eat in food. So void eat won't take any parameters, and what it will do is pretty much go system print a line, pretty much system out print line, and it's gonna say, did I get that right? System out print line. This food is great. And now what tuna and pot pie does, anytime you call the eat method, it would say this food is great. Now that's nice and all, but another thing about polymorphism, and I'm just going to do this for demonstration purposes, we can override the eat method. That if we put it in the tuna class and called it, it'll say this tuna is great now. And let's just do that one more time with pot pie. This pot pie is great. So even though it's inheriting the eat method from the food class, we overwritten it or overrode it with putting a new eat method inside the tuna and pot pie class. So now when you call the eat method in tuna, it says this tuna is great, and now when you call the eat method in pot pie, it says this pot pie is great. So now let's get into polymorphism, now that we have a program that uses inheritance. What polymorphism is pretty well. First, let me describe to you how we built reference variables and objects before. We did something like tuna Bucky equals new tuna, and we didn't really think about what we were doing, we just did it because that's how we were taught. But if you're wondering, alright, why do I need to put tuna right here and tuna right here as well? Shouldn't I only have to put it once to know that I'm talking about that class? Well, the thing is, well, first let me go over what these are. This right here, Bucky, is the reference variable. That means whenever you refer to the variable Bucky, you are referring to controlling the stuff in this class or object, which is tuna. And this pretty much is the data type. So it can control the tuna data type, and this object is of type tuna. But another cool thing is you can do this. And this pretty much is the intro to Sorry. This pretty much is the intro to polymorphism. Not only is tuna of the tuna type, but tuna is also of the food type. So what you can do is some pretty cool things. Anything that inherits from the superclass, which is tuna, or excuse me, the superclass is food, can be assigned to Bucky. For example, tuna, since it inherits from food, can be assigned to Bucky. Pot pie, since it inherits from food, can be assigned to Bucky. And you're saying, alright, that's nice and all, I can assign this, that, and the other thing, but why actually would this be useful in any kind of way? Well, to answer that, I will do one thing which you guys probably need, and that's an example. The quickest example and the most clear thing I can do is build something called a polymorphic array, and this stores objects of different classes in pretty much the superclass type. So let's go ahead and say we have food, and that's the type, and let's go ahead and make an array object named Bucky, and we'll set this equal to new food 2. So now we have an array, and it's called Bucky, and it's of the food type. And remember, like I said, since we have something of the food type, it can hold objects of tuna and pot pie. So for example, Bucky 0 can hold objects of new pot pie, just like that, and we'll set Bucky 1, which is a reference variable, and we'll set this equal to the object of new tuna. And you're saying, alright, well, that's still great. You have one variable that can hold an object and another variable that can hold an object. Yeah, these variables might be of the food class, but I don't see why this is useful still. Well, just wait a minute and trust me, you'll see why in a little bit. One reason for using polymorphism is to use polymorphic arrays, and that would be something like this. You loop through this array, and in essence what it does is it calls each method of this class right here. So let's go ahead and type for int x equals 0, and just put something like x is less than 2. You can also put array length, but you know, you don't want to, and do ++ x. And now what we can do is say something like this, Bucky x dot eat. And what this is going to do is loop through each one of these objects and call the eat method. So it's going to loop through the first object, which was assigned Bucky 0, pot pie, and it's going to call pot pie dot eat, which is say this pot pie is great. The next thing it's going to do is loop through the tuna object, which is tuna.eat, and then it says this tuna is good. So then you save yourself the trouble of making a new object called tuna object. Then you go tuna.eat, and then you have to make an object, and you have to call each method. And I just got rid of my curly brace right there. So what this pretty much does is loop through each of your objects and calls the eat method for each one. Don't believe me? I'll run it right here. It says this pot pie is great, this tuna is great. Bam. How easy is that? So that is pretty much your basics, the polymorphic array. You can assign different objects to variables as long as this reference variable is of the superclass type. And that way, instead of having to build a new object for each one of your having to build a new object every time you want to use a method from that thing, you can build one reference variable of the superclass and assign it to objects of the subclasses and just loop through them with a polymorphic array. So how cool is that? And I know it's really confusing at first, but once I show you some other examples aside from polymorphic arrays, you're going to understand exactly how to use this, how it works, and you'll be a pro at it. So for now, thank you guys for watching. Don't forget to subscribe, and if you have any questions, just leave me a comment and I'll try to answer them. So thank you guys for watching again, and I will see you next time. What is going on, guys? Welcome to your 56th Java tutorial, and in this tutorial I'm going to be talking about more about polymorphism and how you can have polymorphic arguments and also return types and a bunch of boring stuff like that. But I'll try to make it a little exciting, and maybe I'll tell a funny story. Maybe I won't. I guess you guys are going to have to wait and see. If you've been following my tutorials, the first thing you probably noticed is I made a new class called Fatty. And we need to build this class to demonstrate what Fatty can do to food, tuna, and pot pie. If you haven't guessed, he's going to be eating these classes. Because fatties love food, tuna, and pot pie. Trust me, I know. Firsthand. I'm fat. I love them. So we made this Fatty class. Now let's go ahead and make a simple method in here. It's going to do public void digest, which pretty much means eat. But we can't have eat tuna because eat is already method in here. So we're going to have digest, and as a parameter is going to take a food object. So let's go ahead and type food x, and now we can go ahead and do something with that object. Let's tighten that up a bit. That's what she said. So now we're going to pass in a food object, and when we pass in a food object, we're going to take that object, which is now named x, and we're going to call the eat method to that, and bam, that's all we're going to do. So here's what we can do right now. For example, if we had a food object named Bucky, we can pass in the name Bucky, and then it's going to say, alright, whenever we call Bucky.eat, it's going to say this food is great. So whenever we pass in a food object, it's going to call that food method, which is eat right here. But what you didn't know, or maybe you did if you know Java, what you didn't know is anytime you can pass in a food object, you can also pass in objects of its subclass. For example, you can pass in tuna and pot pie. So since this object, or excuse me, this method has the privilege of accepting a food object as its argument, it can also accept any subclasses such as tuna and pot pie. So, oh, what'd you say? You don't believe me? Well, let me just go ahead and prove it right here. Let's go in our main apples method, and let's go ahead and start making some objects. Let's go ahead and make a fatty object, and we'll name it Bucky because that's me and I am fat. We'll say equals new fatty with no parameters. So what we did here is we created a fatty object named Bucky. And let's go ahead and now, once we can use this fatty class, let's go ahead and give us a way to use the food objects. So let's go ahead and create food. We'll create FO for food objects equals new food. And why do we need to create a food object? Because, first of all, put your semicolons. Get out of my way, box. That's what he said. And I crack myself up sometimes. And why did we need to create this object for food? Well, because this method takes an argument that's a food object, so that's why. So now let's go ahead and call this with our fatty object, which is Bucky, because I'm fatty. We'll put Bucky.eat right there. And now let's go ahead and as our argument, remember, or excuse me, that's digest, isn't it? And as our argument for the digest method in our Bucky object, it takes one food object. So we only have this object right here, FO. So let's go ahead and pass that in and see how it works. Okay, run that baby. And it says, this food is great. Wow, that food must be great. Wonder what it is. Probably double cheeseburgers, you fat piece of oh, sorry. And anyways, now you pretty much know how you can pass in objects in the methods. But wait, Bucky, you said that you can pass subclasses in as well. Well, I didn't lie. Anytime you can pass a food object in as a method, as an argument, you can also pass the subclasses, which are in this case tuna and pot pie. So for example, we have this fatty digest method that takes a food object as its argument, but food also has the subclasses of pot pie and tuna. So let's go ahead and make a food, let's name it PO equals new food. Get out of here, and bam, just like that. So not only can we pass in this superclass of food object, we can also copy this because we're lazy, and we can also pass in this object PO, which would be the pot pie. So let's go ahead and run this, and it'll be new pot pie like that. And let's run it and see what we got. This food is great, this pot pie is great. So what point am I exactly trying to make? Well, what we did right here is this. We created an object named Bucky so we can use all the stuff in this fatty class right here. And the only thing is this digest method. So, you know, we don't have a whole lot to work with here. We also created a new food object because this digest method, it took a food object as its argument. Now after that we created a pot pie object. Now this pot pie object is a subclass of this food superclass. So anytime this digest method can take a food argument, it can also take a tuna or a pot pie argument as well. So then I proved that to you guys because I know I'm a liar and I had to prove it to you guys. I called that Bucky object with digest is the food object is my argument, and I also called the pot pie object as my argument. So that is pretty much a way that you can have polymorphic arguments, and you can also have polymorphic return types in the same way. So we just went over arguments right here, but you guys can figure out just return any other one if you want. So that's that for this tutorial. Hopefully you guys learned. If you didn't, then you know, I don't know what else to do. Watch the rest of my tutorials, I guess. Oh, disgusting story. I told you guys that I'll tell you. One of my friends, she went to a well, I don't want to say the name of the restaurant, but she went to a fast food restaurant before, and she got this chicken sandwich, and she bit into it, and it was like creamy in the inside, and she's like, oh cool, like a new cheese on the inside. Must be like a cheese filling or something like that. It tastes like blue cheese or something. Well, anyways, she ended up getting food poisoning, and they found out that in the center of the chicken, it wasn't a filling, it was actually pus in the center of the chicken. So when she bit into it, pus burst out, and she thought it was filling, and she just ate it anyways, and yeah, she got food poisoning. So if you think that's disgusting, leave me a comment, and if you never want to eat a chicken sandwich again, then I don't blame you. But it wasn't from McDonald's or Wendy's, so you guys are still good to eat there. So in any way, thank you guys for watching. Hopefully you enjoyed my disgusting story and my tutorial. So I look forward to teaching you some more, so I will see you next time. Oh, by the way, don't forget to subscribe. What is going on, people? Welcome to your 57th Java tutorial. And this tutorial is going to be not a lot of coding, actually. It's going to be pretty much clearing up a whole bunch of concepts dealing with polymorphism, and trust me, you're going to have a huge, a better understanding of polymorphism by the end of this tutorial. So I just want to go over overriding a method real quick, and something I didn't tell you about. We built this superclass called food and two subclasses called tuna and pot pie. We called a method in food and we called it eat, and we overrode that method in tuna and pot pie. Each of these had an eat method that overrode it. So one thing I didn't tell you about overriding a method: anytime you override a method, you must take the same arguments as in the superclass method. So since this eat argument didn't have any arguments in it, it didn't have like an integer, this tuna can't have like an integer argument for this, and this pot pie can't do the same. Whenever you put an argument in here, this is called overloading, and that's totally different. But again, if the main eat method doesn't take any arguments, which it doesn't, tuna and pot pie can't take any either. And also, in that same path, it has to return the same thing too. So for example, if you returned an integer in here, it would have to, if you returned an integer in the superclass, it would have to return an integer in the subclass as well. And if you're saying, alright, why do I have to do this? Why do I have to not take any arguments and return the same stuff if I'm overriding it and in essence doing a whole nother method? Well, it's so that you can have consistency, and that is just so anytime you can call the eat method in any of your other scripts, then it pretty much guarantees that you can use any of the subclasses as well. So if all of these methods take the same arguments and return the same things, then they are pretty much interchangeable, and that allows you to use a subclass in substitution anywhere you can use a superclass. So that pretty much then you know what to expect. And another thing I want to talk about: anytime you override a method, so for example, we have this food method in our superclass and we overrode it with tuna, we cannot change the scope of this. So for example, this food is public right here. We can't put private void eat. See, we're getting an error already. This changes the visibility of it, and why would you override it with a private anyway? So you just don't want to do that. And as I talked about, overloaded method is not the same as override. What overloaded method is, if you hear anybody talking about this, an overloaded method is a method with the same name, but it has different arguments. So for example, we can do this in I and not get an error, but this is a whole nother complete method. So if someone calls eat with a single argument, then this method is called. But for now, I just want to tell you guys that overloaded and overridden are two totally different things, so don't get them confused. So now that we got that out of the way, in essence, I pretty much just want to tell you that whenever you override a method, you have to take the same arguments and same return types. There, I said it. I just said it in like 3 minutes the other time. So let's go back to our fatty class right here, and let me refresh your memories. We know we can do something like have a tuna reference and set tuna object equal to like new tuna, and as you know, this is the tuna reference right here and this is the tuna object, and we can do this since tuna is a tuna. And we can also do something like food object equals new tuna, and we can do this because tuna is a food. And those are the things we learned in the last tutorials. But what have we not seen so far? What we haven't seen so far is food object equals new food. What about that? Well, this is a problem for many reasons. Tuna and pot pie we wouldn't have a problem with, and this is because when we put variables in here like color, shape, tuna has a color, tuna has a shape, pot pie has a color, pot pie has a shape. Food is too general. It doesn't really have a color. It says what color is food? I don't know. What shape is food? I don't know. And if you say, alright, I can eat a tuna, I can eat a pot pie, but I can't eat a food. Food is really too general. And I know that there might be some exceptions to this, but for the sake of programming, there are some classes that are just too general that you don't want to create objects on. And this food class is one example. So if we had a food class, we wouldn't want to give it any variables like color, or a shape, because food in general doesn't really have a color or shape. So alright, that's nice and all. I kinda knew that already, Bucky. So why are you telling me this? I mean, I'm not giving you guys a tutorial to tell you guys that tuna has a color. But what I am giving you guys, teaching you guys, it says, even though we can't create food objects, like right here, we need this food class still for inheritance and polymorphism. But when we create this class, we want to make sure other programmers can't create food objects either. So how can we make this food class right here, and how can we kind of bulletproof it to make sure that no one creates an object and they only use this class for inheritance and polymorphism and stuff like that? Well, luckily, the cool people who invented Java gave us this keyword, and it's called abstract. And how you make a class abstract is type abstract, abstract, right before the class. And what this does is mean, alright, you can use this class right here, the class of food, but you can't create any objects from it. Oh yeah? Wanna bet? Look at this. Food object equals new food object right there. Oh, I did it. Oh, look, I got an error. I guess Bucky is right. I can't instantiate the type food, and that pretty much means you can't create an object anymore. So if we take that abstract away, look at this. The error, it goes away, and now we can create an object. So again, what abstract means is that you can't create an object from that class, but you can use that class for things such as inheritance and polymorphism and stuff like that. And that is so when you have a broad class that you only want to use for those kind of things, then it kind of bulletproofs your programming. And in the next tutorial, we're going to be going over the two different types of classes. Abstract we went over in concrete, and I'm going to be showing you guys an example of why it is useful and also what abstract methods are. So this next couple tutorials is more of general ideas, and then we're going to be building programs to use these ideas and put them to use. Use them and put them to use. Did I say that right? Man, good enough. But thank you guys for watching. Hopefully you guys understand that anytime you override a method, you need to take the same arguments, and also the beginning of what an abstract method abstract class is. So again, thank you guys for watching. Please check out my next tutorial, and I will see you next time. Oh, by the way, don't forget to subscribe. Alright guys, welcome to your 58th Java tutorial, and in this tutorial I'm going to be talking about the two types of classes. And in case you didn't already know, we already talked about the two types of classes. I just didn't tell you the technical definitions of them. Now you guys already know what an abstract class is from the last tutorial. Might as well put that back there. So an abstract class is a class that you can't create objects from. So it's only useful for polymorphism and inheritance and stuff like that. In these other classes that aren't abstract, even though they don't have a name, people call these classes concrete. And a concrete class is a class that's specific enough where you can make an object, you can make an object from it. So even though it doesn't say concrete, that's what people call it, just because they have to call it. They just don't want to be like not abstract. So again, food, you wouldn't want to create something because it's too broad a topic, but tuna and pot pie, those are pretty specific, aka concrete. So you can create objects from concrete classes but not abstract. So again, let me demonstrate this by saying, alright, whenever we try to create a food object, it's too broad and abstract, so it gets an error. But if we go ahead and create, we can have this food reference, but if we create it from the class like new tuna, since this isn't abstract, we don't get well, if I got rid of that, then we wouldn't get an error right here, because tuna has no restrictions. We can create objects from this. Now let's get rid of this and move on to our next topic. And so you know what an abstract class is, and it pretty much is useless unless you extend it or it's inherited from something. And as you can see, tuna inherits food and pot pie inherits food. If nothing inherited food, it'll be useless because you can't create objects from it. So that's what an abstract class is. But just to make things more confusing, I want to tell you that methods can be abstract too. And what exactly is an abstract method? Well, an abstract method is a method that must be overwritten. So for example, we created this method in food. And since tuna and pot pie inherited food, we created a method eat in tuna and a method eat in pot pie, and both of these overwrote food. I mean, this wasn't necessary that we created these methods, but we did it anyways just for fun. So again, an abstract method is a method that must be overridden. In a sense, it must be overwritten, which means you need to create a body for it. Then this body in the main food class right here, this is unnecessary whenever you're creating an abstract method. So let's go ahead and create an abstract method right here. Let's go ahead and get rid of everything in our food class. How would we create an abstract method? Pretty much the only thing you need to do is add the head and a semicolon. So do public, we'll make it public, abstract, since it's an abstract method, void eat, since it doesn't return anything and it's named eat. And now you can see this is a method, but it doesn't have a body. And if you're saying, alright, I never created a method without a body, well, since tuna needs to overwrite it, pretty much it needs to create a body for it, and pot pie needs to create a body for it as well, then that is why in your declaration right here, you don't need a body right here. So again, an abstract method in your superclass, it doesn't need a body. So another thing I want to point out, anytime you have an abstract method in a superclass, that entire class needs to be labeled abstract too, right there. So you can't have like an abstract method and you can't have this class be not abstract, or else you're gonna get an error like that. So someone's knocking on my door, I think. Hold on. Oh, I'll let them keep knocking. I'll get it after this tutorial. And another thing I want to point out is when we declared this public, remember I said I can't change the scope when we override it, so we need to make these public as well. So we'll make that public, and if you see that little error right here, multiple markers can't reduce the visibility, that is why. Anytime you see an error with the word visibility, you probably need to change public to private or private to public, or add one or the other. So again, like I was saying, anytime you have an abstract method, you need to make the class abstract too. But here's the thing, you can have an abstract class but have abstract or non-abstract methods inside it. So again, and this is we're getting an error because of something else here, because anytime you have a non-abstract method, you need a body. But anyways, I just wanted to point that out. Anytime you have an abstract method, it needs to be inside an abstract class. But anytime you have a non-abstract method, it can be inside an abstract class. Well, you just heard it. I don't need to repeat myself. So the last thing I need to point out is, let's go ahead and make this method abstract again, just like this. Anytime you have an abstract method, you need to implement it in in any of the subclasses that extends to the superclass. Now I know that sounds confusing, but listen to this. Alright, this tuna class and this pot pie class both inherit from this main food class, and this food class has an abstract method of eat in it. That means this tuna class and this pot pie subclass, they both need to use the eat method, or in other words, they both need to implement or override this eat method. If you don't have this eat method, then you're gonna get an error in your class, just like this. Type pot pie must implement the inherited abstract method food.eat. So again, anytime you have an abstract method in a superclass, then the subclasses need to override that method. And that's like making a promise. This food says, alright, you want to inherit from me? Okay, I'll let you. But I'm telling you, I have this abstract method, and if you inherit from me, you're going to need to override it. And Papa's like, Alright, I promise I'll override it. Since you have an abstract method, I promise if you let me inherit from you, I will override it for you. So, if like the classes could talk to each other, that's kind of the conversation they would be having. And if you're saying, alright, if I need to override this method anyways, what's the point of even having it in here? Well, it's pretty much for consistency and some polymorphism, and I know that doesn't make a lot of sense, but in the next tutorial I'm going to be building a program to demonstrate everything I went over in the last two tutorials. These last two tutorials were pretty much the rules and concepts that you have to follow, and I couldn't just skip over it because it's incredibly important for what we're going to be learning in the next couple of tutorials. And this is pretty much the core of polymorphism, these rules. So in like 5 tutorials ago, when I called a class, or excuse me, it was an interface and I implemented it, that's what implemented means. Implement means pretty much you need to override the abstract methods. So that's enough for this tutorial. I probably should go see who's knocking on my door, but thank you guys for watching. Don't forget to subscribe. Oh, I got like phlegm building up in my throat. But anyways, thank you guys for watching. Don't forget to subscribe, and I will see you next tutorial. What is going on, guys? Welcome to your 59th Java tutorial. And if you've been watching the last couple tutorials, then we pretty much learned all the really basic concepts of polymorphism and inheritance and stuff like that. So in this tutorial, we're going to be putting all our knowledge to use and building a program that pretty much gets a class and puts objects in an array. And it sounds confusing, but you're gonna see what it is eventually. But before I get into programming, I want to show you guys that I got rid of all my other classes because I'm gonna need a better example, and I thought that this would clearly or better demonstrate. So I made a new dog class, and I made a new class called fish, and I made a new class called animal. And since dog is an animal and fish is an animal, then I had them both extends or inherit from the class animal. And I didn't want to do that just because it took time, but I pretty much just made these classes and I have nothing inside of them. So if you want to go ahead and do that, you can follow along with me. So then, here's a scenario. We made these 3 classes called dog, fish, and animal, and our boss comes in and he's like, alright, Bucky, I need you to program something for me. And I'm like, what is? He's like, I need you to make a new class called, we'll name it dog list or something like that, and in this class I want you to have an array that we can add dog objects. So like I said, an array can hold many things. It can hold numbers, it can hold strings, it can also hold objects, and this comes into use, well, we're going to be finding out why a little later. But in this tutorial we're going to be building a new class and a new array to hold dog objects. Why? Because our boss told us to. So let's go ahead and do it. The first thing I want you to do is go ahead and under your package, under your source, right click it and click a new class. I know you probably can't see it, so I will move it down. Source, new. Wow, now you really can't see it. But anyways, if you click a new and class, you get this thing that pops up, and just go ahead and put dog list or something like that. And now let me move this back, so there we go. Now we have, let's see, 1, 2, 3, 4, 5 classes, and we have this new dog list class. And in this class we're going to be building an array to hold objects from this dog class, and the fact that it extends animal is irrelevant for now. So we have this dog list class, and our boss wants us to build an array, so let's go ahead and do that first. Let's go ahead and make it private because no need to make it public. Dog, and we're putting dog, and we'll name the array the list. And we'll set this equal to new dog with a parameter of 5, or an array length of 5. And we put this dog and dog, even though we named the array the list, we put dog and dog right here because that is what objects it's going to be holding. It's going to be holding stuff from the dog class. So now that we have an array name named list, let's go ahead, and the only other thing we're going to need to work with our array is a counting variable. So let's go ahead and name private I equals 0. You can set equal to x if you feel more comfortable with that, but what's this error saying right here? Alright, we need an int. Private int I equals 0. So now we have an integer that's just a counting variable that's going to help us work with our array. So now let's go ahead and build a new method to add dog objects. So again, or not again, we need a method named public void. We'll name it add. You can name yours whatever you want. I'm just going to name it add because it makes sense. And as a parameter, whenever we call this, it's going to take a dog object and we'll name it D for now. Short and sweet. And the first thing we want to do in this method is do an if statement. So let's go ahead and make if, and we'll put I, which is our counting variable that's 0 now, is less than the list.length. And what this pretty much does is check if your array is full or not. So if I, the counting variable, is greater than 5, then your array is already full. So it would just, the method would run, but it wouldn't add another one to array because this can only take 5 elements. So if it were 7 and we tried to add one, then it wouldn't do anything. So if it is less than length, which means if it still has room in our array, what do we want to do? Well, the first thing that we want to do is put the list in I, which would be 0 now, and we want to set it equal to D. So we're pretty much just going to loop through the array, and every time we call this method, add an object to that array element. Then just give us a little system out print line on screen, something that says like dog added at index space, and we'll put I right there. Come on, there we go. And we'll just, looks good right now. So now we have just a little something on our screen that we can see visually because, we want some feedback here. So next, we'll just increment through I. So here's what this method is doing. It pretty much checks if your array is full or not. If not, it adds that object at that index. And then it says, just gives us a little message on the screen. And then it goes to the next counter so we don't keep adding it in the same index in our array. So now we built this class, just like our boss said, that has an array named the list, and it's going to loop through, and every time you call this method, it's going to add a new object to the array. So let's go ahead and do this in our main method. I named mine apples. I don't know why, but I did. So now let's go ahead and make a dog list object. So let's go ahead and put dog list. I'm going to name my DLO. You can name your object anything you want. And then just put equals new dog list. So yours should look the exact same as mine, except if you didn't want to name it DLO, you don't gotta. So now we can go ahead and create a dog object because we need one as our parameter. So we create dog D, or if you don't have a dog class, then whatever you have, and we'll set it equal to new dog object, just like that. Doesn't take any parameters because it doesn't even have any constructors or anything. Now what we have to do is pretty much call the method in our dog list. So use that object DLO. Whoa, embarrassing. DLO, that's where I meant to type it, and we have a method called add in there. Remember, that's what our method was called, and it takes a parameter of an object, a dog object, and we have a dog object right here, dog D. So let's go ahead and put D as our parameter right there, and that's it pretty much. Just run this baby, click OK, and now if everything goes right, it should say dog added at index 0. And if we added another one, it would say dog added at index 1, and it would go 2, 3, 4, and it would go all the way, and that is because we set this equal to a length of 5, which means index 0, 1, 2, 3, and 4. So that's your real basic tutorial on our how to create an array to add objects into it. But then, what if our boss comes in and says, yeah, come in, boss. Hey Bucky, I got a little problem. What's that, boss? Alright, you know how I told you to create a dog list to hold dog elements? Or excuse me, dog objects? Well now, the people we're working for, they said, alright, I want it to hold fish elements too. So how are we going to fix this problem? Well, that is a problem for the next tutorial, and that's what we're going to be doing. And trust me, you don't just add another entire class called fish. What we're going to do is making this bigger and better and you know, it's just going to be awesome, and you're going to learn a lot in the next tutorial. So thank you guys for watching. And another thing, my 500th video that I have like 491. My 500th video is going to be the best video and the biggest surprise for you guys ever. So you do not want to miss this 500th video. It's probably being released this weekend, but it is going to be incredibly awesome, and trust me, you guys are definitely going to want to see it. So for now, thank you guys for watching. Don't forget to subscribe, and I'll see you next tutorial. What is going on, guys? Welcome to my 60th Java tutorial. And in the last tutorial, we went ahead and we built a new array, and in essence we built a whole new class to create this array to hold dog objects. But then at the end of the tutorial, got a little knock on our door, and our boss was like, alright, you know how you created that for dogs? Well, actually I need you to create one for fish as well. And you know, that's nice and all, so what can we do? What are our options? We can go ahead and create a new fish list and do this all again, or you know, then we're gonna have, if he comes back again and tells us to do it with dolphins or cats, we're gonna have to keep doing that again and again and again. So instead of just having to create class after class after class, I wish there was a way where we can only create one class and it could hold fish objects and dog objects and any kind of animal that we want. So then when our boss says, alright, I need you to actually create one to hold birds, we're going to be like, oh, you know what? Already done. Because we already built a sufficient and effective program to hold all classes of animals, even the ones that we didn't even know that were created yet. So how would we do that? Well, this dog list is nice, but let's go ahead and delete that right now. Delete and OK. So instead of just creating a bunch of different classes to hold objects, let's go ahead and make one final thing, and we're going to name it animal list. So let's go ahead and we can delete everything out of our main apples, or whatever your main method is. And now let me get rid of that error. And now let's go ahead and create a new class by right clicking source, new class, and we'll go ahead and name this animal list. And this is going to be pretty much, let me run this little X is annoying me, there we go. And this is pretty much going to be the class that has our array to hold any type of animal, whether it be dog, fish. If you decide to create a dolphin class later, if you decide to create a hermit class later, it's going to already be able to hold that. So the first thing that we're going to want to do is create an array to hold type animals. And remember, these dog, fish, since they extend animals, all of these are type animals already. So let's go ahead and put private animal. Animal, and we'll just name it the list equals new animal 5. So what this pretty much means is we created an array named the list, and it can hold 5 objects of type animal right there. So after this, let's just go ahead and make our counting variable private I equals 0, and now we can go ahead and build, I always do that, int I equals 0, and now we can go ahead and build our method, and that's public void, we'll name it add still, but we have to spell void right, add, and we'll put animal A. So now it takes one parameter, which is an animal object, and now we'll just do that test again. If what do we name it? The list, or actually we want to do if I is less than the length. If I is less than the list dot length, so it would be 5 in this case, but just in case you change this, then you won't have to change it each time, so that's why I'm doing that. So if I is less than the list length, what do we want to do? Let's go ahead and do the exact same thing we did last time. The list, the index for that, which would be I, so at first when it would assign the list 0, set it equal to A, which is the animal object. Next, let's just give us a little prompt on the screen like system out print line, and we'll just have animal added at index space plus I. So this pretty much just gives you a little message on the screen, and the last thing we want to do is increment I, because if we don't, it's just going to keep adding to that same index over and over again. So each time this runs, it's going to change that counter variable that allows us to move to the next element in our array. So now that we got this animal list, it's going to take any animal object we have, and let's go ahead and I'll show you guys that right now. So in your main class, whatever you named it, I named mine apples, still don't know why, we can go ahead and create an animal list object from this animal list we just created. So let's go ahead and put animal list ALO, you can name it whatever you want, new animal list, bam, just like that. Now let's go ahead and create a new dog object, because remember that method takes an animal object as its parameter. So go ahead and actually, you know what I'll do? I'll create a new dog object and a new fish object. So dog, we'll just name it D because it's short and sweet, equals new dog, just like that. Then I'll put fish from our fish class, create an object from here, F equals new fish, like that. Now we can go ahead and call the add method in our ALO.add. First of all, we'll add that dog, and now we'll do ALO.add, and now we'll add that fish object. So now if we go ahead and run this, you can see, alright, animal added at index 1, this is the dog object, and animal added, animal added at index 0, this is the dog object, and animal added at index 1, that's the fish object right there. So again, what we did, real quick overview, we created an object so we can use the methods from this animal list class. We created two objects of dog and fish, which were both animal type, and we go ahead and we just called the add method. So it first added that dog element to index 0 and add the fish element to index 1, and we can call that 5 times, and then that's it. Then our array is full. If we call it after that, then it's gonna run the program, but it's not gonna add it to our array because it's already full. So this is a much smarter array than we built last time, because now if someone wants to create a new class that was like hermit crab, like I said before, all they need to do is put extends animal, and it's automatically an animal type. So that way we don't have to create a new array for dog, fish, hermit crab, dolphin, gopher, woodchuck, beavers. We just needed to create this one class right here, and it took care of all those problems. So if you think this array is pretty smart, just wait till the next tutorial. We're going to build this computer program even smarter and better than this. And if you didn't think that is possible, then trust me, just wait till my next tutorial. And one other thing, and I know you've heard me before if you watched my last tutorial, my 500th video is going to be amazing, and it's going to benefit no one but you guys. So a couple of you people might already know what that means, what I'm hinting at, but trust me, it's going to be the best video for you guys ever. So thank you guys for watching. Don't forget to subscribe, and I will see you next tutorial.